Доброго дня усім. Привіт, шановні учасники Data Conference 2021 року від компанії EPAM. Всім привіт, всіх раді вітати на нашій сьогоднішній події, на нашій сьогоднішній конференції. Відразу хочу зробити декілька оголошень. Ми будемо стартувати рівно о 10:30. Так, разом з вами, шановні колеги. І до 10:30, будь ласка, приєднуйтесь, доєднуйтесь, подивіться, чи у всіх все відкрилось. Якщо говорити про нашу конференцію, на нашій конференції присутні декілька потоків. Ви присутні на потоці Data Engineering, це наш основний потік на конференції, і, власне, якщо дивитися на наш організаційний, як то кажуть, порядок дня, ось, ми можемо зробити декілька оголошень і маємо приємність зробити ці декілька оголошень. Ну, перш за все, шановні учасники, сьогодні будуть розігруватися призи. Ось, і цей розіграш призів буде відбуватися в декілька етапів. Ми хотіли би оголосити про перший, як то кажуть, етап розіграшу призів. В нашому YouTube-каналі ви побачите лінк, так, на нашу Facebook, як то кажуть, сторінку, і найкращий приз дістанеться тому учаснику, хто зробить найкращий комент, так, про нашу конференцію, найцікавіший коментар про нашу конференцію. Ось, будь ласка, заохочуємо вас до цього. Другий момент розіграшу призів у нас буде пов'язаний з нашим інстаграм-каналом. От, і, власне, ми хочемо попросити вас трішечки покреативити, зняти найцікавіші моменти нашої конференції на відео і запостити в себе в інстаграм-каналі. Зрозуміло, що учасник, який створить найцікавіше відео, він отримає аналогічний приз. Ось, ну і, звісно, не можна, як то кажуть, на конференції тільки слухати, потрібно ще й проактивно або активно працювати. І третій розіграш призів у нас відбудеться під час роботи з нашим квізом або квізами, тому що декілька потоків, відповідно, будуть квізи. От, і з 13-ї години, з 13 до 13:30 якраз буде відбуватися розіграш призів, пов'язаних з нашими квізами. Тому, будь ласка, шановні колеги, заохочуємо вас бути проактивними. От, ну, а перш ніж ми розпочнемо, хотілося б сказати пару слів і про нашу конференцію, про актуальність теми і про нашу компанію загалом. Так? От, ну, якщо подивитися на актуальність тематики, взагалі роботи з даними, то можемо для себе провести таку аналогію, таке порівняння. Якщо у 20 столітті основним рушієм економіки або бізнесу у світі були гроші, тобто можливість генерації достатнього об'єму грошей для того, щоб вести свій бізнес, то у 21 столітті ми перейшли плавно в епоху діджиталізації, ми перейшли в епоху роботи з технологіями, інформаційними технологіями. І, власне, ми можемо сказати, що інформація – це кров економіки 21 століття. Основою інформації є дані. Так? Диявол криється завжди в деталях. І от якщо говорити про, власне, роботу з даними, це є один з таких мейнстрімів, так? Тобто один з головних напрямків, в принципі, роботи будь-яких великих IT-компаній світу, і не тільки великих IT-компаній світу, а IT-компаній світу, які намагаються продукувати якісь цікаві рішення, виводити якісь цікаві продукти на ринок або сервіси. Тому, власне, дана тематика, вона буде тільки, актуальність даної тематики, вона буде тільки зростати. І, власне, якщо говорити про компанію EPAM в цьому контексті, то ви знаєте, що компанія EPAM є однією з найбільших IT-компаній світу. От, і якщо говорити про, наприклад, про проєктне портфоліо нашої компанії, а в ньому більше 300 проєктів таких величезних, так, можна сказати, Це, безумовно, значна частина цих проєктів, вона базується на роботі з даними, з дата-технологіями, з дата-інженірингом, як таким. І, власне, розвиток компанії EPAM, вона завжди надає можливості не просто роботи на цікавих і перспективних проєктах, а вона завжди надає можливості розвитку власних компетенцій в даному напрямку. Так? Тому, будь ласка, слідкуйте за нашими конференціями, слідкуйте за нашими курсами, слідкуйте за нашими пропозиціями і, відповідно, доєднуйтесь до нас, ми будемо з вами залюбки співпрацювати. Якщо говорити про якісь додаткові акценти нашої конференції, то варто відзначити наших топових спікерів. Це люди з величезним досвідом, це колеги, які присвятили практично все своє життя роботі в нашій IT-сфері. І, власне, ті колосальні знання, які вони накопичили протягом цього періоду, вони залюбки будуть ділитися цими знаннями сьогодні з вами, шановні друзі. І, власне, тому по структурі програми передбачено декілька речей. Перша річ, ми будемо транслювати, безумовно, відео в записі наших спікерів, але після кожного відео в нас буде, як то кажуть, лайв-сесія, спілкування з спікером вживу. Тому, будь ласка, ми дуже заохочуємо вас задавати будь-які запитання, які вас цікавлять за даними тематиками, так? І активно спілкуватися, я би сказав, навіть проактивно спілкуватися з нашими спікерами. Я думаю, що вам сподобається цей формат, тому що цей формат, він дає можливість і зосереджено попрацювати з відеоматеріалом, послухати його, власне, занотувати собі. Завжди радимо вам тримати біля себе якийсь блокнот і ручку або гаджет, в якому ви будете записувати ті чи інші питання, робити ті чи інші помітки, коментарі і так далі. І, власне, після цього використовувати цю можливість живого спілкування з нашими спікерами для того, щоб отримати ті відповіді, які вам потрібні в контексті вашої роботи. Ну що ж, 10:30, я думаю, ми можемо розпочинати. І, власне, з величезною приємністю я би хотів надати слово, вступне таке слово, нашому колезі Богдану Гаю. Будь ласка, Богдане.
Всім доброго ранку. Мене звати Богдан Гай. Я очолюю українську компетенцію Big Data компанії EPAM. Мені надзвичайно приємно відкривати Open Data Conference. Радий бачити, що в нас є більше 400 однодумців, які зареєструвались та з нетерпінням чекають старту. Я впевнений, що ви зможете почерпнути нову для вас інформацію, отримати безцінний досвід, який ви зможете використати на своїх проєктах чи навіть у повсякденні. У світі акумулюється все більше та більше даних. Людство виходить на цифру порядка 100 зетабайт на кінець 2021 року. Ми потребуємо і споживаємо все більше і більше інформації. Інтернет речей, кіберпростір, віртуальна та доповнена реальності – це тільки одні з багатьох чинників, які впливають на цей тренд. Жодна цифрова трансформація, яка так необхідна бізнесу, не обходиться без обробки даних та генерації дата-продукту. Пандемія також з'явилася на деманді, фактично підштовхнувши компанії збільшувати інвестиції у власну трансформацію. Отже, ці цієї конференції є поширення унікального досвіду та експертизи, згенерованого в компанії EPAM. Про це ми розповімо згодом. Привернення уваги до проблематики великих даних та рішень, які застосовуються при їх вирішенні для все більшого кола людей. Фокусування на інженерній досконалості та інженерній культурі. Поширення best-практик для застосування на прикладі реальних кейсів. Постійне вдосконалення. Ми прагнемо вдосконалюватися і давати якісний контент, тому зворотній зв'язок від вас нам в цьому дуже допоможе. Ні для кого не було і не є секретом, що саме в компанії EPAM сконцентрована найбільша експертиза розробки рішень по бігдаті, дата-аналітиці та дата-інтеграції. Кількість людей в глобальній практиці виросла за неповних 4 роки більше, ніж удвічі, і на даний момент налічує майже 4 тисячі людей по всьому світі. Трошки більше чверті цих людей знаходяться в Україні. Проектний портфель на даний момент налічує майже 700 дата-проєктів. Доменні області, які ми покриваємо, самі різноманітні. Енергетика, healthcare, фешн, фінтек, entertainment та геймінг, тревел та багато інших. Технологічне покриття також дуже щільне. Ми працюємо як з дуже відомими клаудами, такі як AWS, Azure, GCP, так і маловідомими та екзотичними, наприклад, як Alibaba Cloud. Також ми використовуємо самі різноманітні мови програмування, також і профільні фреймворки. Більше того, наші партнерські угоди з Azure, AWS, GCP, Databricks та іншими ключовими гравцями та вендорами привело нам суттєво нових та вимогливіших клієнтів. Для одного з них, для прикладу, ми побудували Data Lake, де зберігається понад 100 петабайт неструктурованих даних. Та ця кількість постійно зростає. В розрізі України, щоб задовольнити потреби ринку, ми відкриваємо та розвиваємо нові локації. До Львова та Києва, в яких був зосереджений основний потенціал. В цьому році доєдналися Харків, Дніпро, Івано-Франківськ та Вінниця. Ми маємо дуже серйозні плани на східний та південні регіони в наступному році. Для того, щоб відповідати вимогам ринку та вимогам наших клієнтів, ми постійно інвестуємо в наших людей. У нас діє унікальна ретренінг-програма, яка покриває основні технології розробки, надає людям можливість отримати практичні навички. Оскільки технології дуже швидко еволюціонують, ми обновляємо дану програму кожні 2 роки. У нас діє R&D-лабораторія, де ми допомагаємо розвивати молоді таланти. В цьому році R&D-лабораторія почала діяти в межах всієї України. У 2021 році до нас приєдналося більше 40 молодших спеціалістів. Та ми плануємо подвоїти ту цифру у 2022 році. У нас діє активна ком'юніті, яка генерує більше 30 внутрішніх івентів щорічно. Ми активно контриб'ютимо в open source. В практиці є близько 10 активних акселераторів та продуктів, які ми вже виклали у відкритий доступ. Один з таких продуктів є DataHub, який був впроваджений і успішно працює в продакшені на багатьох клієнтах. Досвід та експертиза, про які було сказано вище, привели до того, що у 2017 році виникла ідея мати свій власний унікальний івент, де ми зможемо поширювати не тільки наш досвід в дейта-розробці, але також пропагувати інженерну культуру та наші цінності назовні. Ми провели 2 конференції у 2018 та 2019 році, які зібрали порядка 200 учасників сумарно. Ми зробили висновки, що контент, який ми генеруємо, цікавий та потрібний людям. Цьогорічна конференція пройде у новому форматі. Вперше ми робимо її онлайн. Є декілька цікавих особливостей, які я хочу підсвітити для вас. Локаційна диверсифікація спікерів. Цього разу у нас будуть представлені 13 спікерів з різноманітних локацій. Це США, Канада, Нідерланди, Польща, Болгарія, Сполучене Королівство та інші. Маємо плани представити ще більше локацій, в яких зосереджені наші девелопмент-центри в наступному році. Багатопоточність. Ми розбили конференцію на 3 потоки, щоб ви могли вибирати найбільш цікавий для вас виступ чи напрямок. Залучення консалтингу. Іншим нововведенням є долучення консалтинг-спеціалістів. для того, щоб максимально розкрити глибину перетворення бізнес-проблеми клієнта у рішення. Панельна дискусія. Цього разу у нас вперше буде проводитись панельна дискусія з технологічними експертами самого високого рівня, які будуть готові до онлайн-дискусії з аудиторією. Ентертеймент. Також, оскільки конференція онлайн і втримувати фокус на протязі 5 годин підряд дуже важко, ми додали трішки ентертейменту. Ми постійно вдосконалюємося. І для того, щоб ставати кращими і давати вам все більше якісного та унікального контенту, нам потрібний зворотний зв'язок від вас. Дуже розраховую на ваш об'єктивний фідбек та конструктивні пропозиції. Дякую за увагу.
Ну що ж, друзі, усім привіт ще раз, хто доєднався. Я знаю, що у нас доєднуються наші колеги. Я дивлюся, що кількість учасників зростає. Це дуже приємно, тому що ви демонструєте абсолютно безпрецедентну увагу до нашої події. Якщо говорити про нашу конференцію, ми можемо сказати, що нам потрібно, напевно, трішечки краще познайомитися один з одним, так? І давайте тоді поговоримо з вами, шановні колеги, про найцікавіші факти, так, про компанію EPAM загалом. Давайте подивимось, що ви знаєте про нас, так, а що ми можемо вам розповісти додатково. Так? Якщо говорити про нашу компанію, то можемо сказати, що наша компанія є дуже публічною, так? Насправді наша компанія є публічною компанією. Акції нашої компанії розміщені на Нью-Йоркській біржі. Цікаво, чи ви знали про цей факт. Компанія була заснована в 1993 році. І нашими замовниками є топ-500 світових компаній з відомими світовими брендами. Наприклад, Epic Games, UBC, Bacardi, Burberry і інші. Тому, якщо говорити про EPAM, так, то компанія EPAM зосереджує собі певного роду унікальну експертизу в багатьох галузях знань, і, зокрема, однією з таких галузей знань є, власне, інженіринг даних, дата інженіринг. І, власне, якщо подивитися, так, наприклад, на проектне портфоліо компанії, то в даний момент, повторюся ще раз, у нас є 300 плюс актуальних проєктів з клієнтами світового рівня. Як ви думаєте, з якого року компанія EPAM почала своє функціонування в Україні? Можливо, ваші варіанти відповідей. Загалом було б добре позначити в чаті, колеги, звідки ви, так, з якої локації під'єднались до нас. Це було б надзвичайно цікаво подивитися на географію наших учасників. Ну і, відповідно, ви можете написати варіанти відповідей. Варіант відповіді, так, на дане запитання в нашому чаті. Будь ласка, колеги, які доєднались, проговоріть, з яких ви локацій, пропишіть. Дуже цікаво було б подивитися на локації. Будь ласка, колеги. Так. Давайте подивимось. Харків, прекрасно, Київ, чудово. Бачите, яка у нас вже такий розкид іде по Україні. Дуже добре. Ще, колеги. Львів. Відмінно. Львів. Добре, дуже добре. Так, абсолютно правильна відповідь, шановні друзі, що компанія EPAM в нас функціонує в Україні з 2005 року. І, власне, сьогодні ми маємо з вами 27 листопада. А скажіть, будь ласка, чи ви знаєте, що в нас 28 листопада буде величезний ювілей 16 років EPAM Україна? От, тому ну, така цікава інформація для нас, так, ви розумієте, що така кількість років на українському ринку, і не тільки на українському ринку IT, вона, звісно, дається в знаки. Тому компанія EPAM, якщо подивитися на неї у фактах і цифрах, декілька років підряд знаходиться і знаходиться і продовжує знаходитися у топ-50, у рейтингу топ-50 компаній, IT-компаній України, найбільших і найкращих IT-компаній України за версією DOW. Якщо говорити про, власне, проєктне портфоліо компанії EPAM, то ми можемо відзначити, що в нас присутні абсолютно різні домени. Зокрема, ми можемо з вами говорити про те, що у нас є проекти в фінансовому домені, проекти, дуже велика кількість проєктів в сфері охорони здоров'я, в сфері медіатехнологій та інформаційних технологій, власне, автомотів проєкти, так, або проєкти в галузі автомобілебудування, робототехніки і так далі. От, детальніше, друзі, ви можете дізнатися про цю інформацію і про можливості, які надає компанія EPAM, для того, щоб ви могли здобути цей досвід, цю унікальну експертизу. Співпрацюючи з компанією, ви можете дізнатися детальніше на нашій сторінці careers.epam.Ukraine, тобто UA. Відповідно, заходьте на цю сторінку, дивіться на можливості, переглядайте їх регулярно. Наша компанія активно набирає спеціалістів, активно навчає, як я вже казав, спеціалістів, і буде рада нашій співпраці. Якщо говорити про кількість спеціалістів в компанії EPAM, давайте друге запитання задам. Дуже цікаво було би почути вашу думку, ваші версії. Скажіть, будь ласка, як ви думаєте, яка кількість спеціалістів присутня зараз у компанії EPAM в Україні? Підкреслюю, не загалом в EPAM, а в Україні. Будь ласка, ваші версії. Сміливіше. Бачу, Ужгород доєднався. Чудово. Так, Луцьк, прекрасно. Так. 100 тисяч. Ну, хіба що, звісно, ми наближаємось до великих цифр, якщо взяти взагалі компанію EPAM як таку, так, в світі. От, але якщо говорити про Україну, то це ми перейшли певний рубіж. Так, бачу різні оцінки. 10 тисяч бачу, 11 тисяч бачу, 12 тисяч бачу. Так, ще варіанти. Сміливіше. Це цікаво. Ваші думки з цього приводу. Насправді, друзі, Василь Гай, він був наш учасник конференції, він був дуже близький до правильної відповіді. Нас більше 12 тисяч. 12 тисяч плюс. Так? Тобто, плюс такий, не те, що невеличкий, а солідний плюс, так? Більше 12,5 тисяч чоловік в Україні, це компанія EPAM. Знову ж таки, ми підкреслюємо і хочемо підкреслити, що одним з аспектів нашої стратегії є, безумовно, всебічне покриття України, так, відкриття наших делівері-центрів в найбільших містах України, і ми активно рухаємося в цьому напрямку. Безумовно, розширення і зростання наших професійних спільнот, наприклад, знову ж таки, взяти Big Data сегмент, взяти, наприклад, там бізнес-аналіз, взяти Product Management і так далі. Тобто ми зростаємо в різних керунках, так, і, власне, ще раз можу сказати про те, що стратегією компанії є генерування унікального value для кожної людини в плані її професійного росту і професійної підготовки. Це дуже і дуже важливо. Тобто це people-centric company, так? Тобто філософія. Відповідно, я думаю, що цими можливостями варто користатися і відтак рухатись і створювати якісь цікаві речі разом. Дивлюся на коментар. Владислав, чи вірно я зрозумів питання? Ви маєте теоретичний досвід, але проекти вас не розглядають через відсутність комерційного досвіду, проблеми відсутності дата-проєктів вашій компанії. Не знаю, що це за такі запитання. Ні, насправді у нас присутні і досвід, і знання. Відповідно, друзі, давайте писати питання по суті в нашому чаті. Якщо у вас будуть якісь запитання, будь ласка, пишіть коментарі. Ми будемо завжди раді відповісти на них. Ну, а ми продовжуємо наше знайомство. І, як я вже казав попередньо, ще декілька фактів про компанію EPAM. Наші офіси відкриті в 12 містах України. Власне, зокрема, з приємністю, звісно, це є Львів, Київ, Харків, Дніпро, Вінниця, Одеса. Фізичні офіси, вони вже відкриті там, функціонують багато років. Наприклад, нові офіси у нас відкриті цього року в Івано-Франківську, Чернівцях, Хмельницькому. Працюють коворкінги і планується відкриття, власне, вже фізично великих офісів у 2022 році. На черзі в нас Херсон. Ми йдемо до вас, колеги, Миколаїв, Запоріжжя, і інші міста. Власне, компанія EPAM не лишається, як то кажуть, осторонь. Ми завжди намагаємося бути на вістрі тенденцій, так, і, власне, зараз ми активно працюємо і розвиваємо можливості віддаленої співпраці в дистанційному режимі зі спеціалістами зі всієї України. Безумовно, у зв'язку з ситуацією, з пандемічною ситуацією в світі, і, зокрема, в нашій державі. Тому, якщо говорити про власне можливості співпраці, вони є надзвичайно широкі. Як ви можете переконатися, масштаб діяльності компанії, він насправді вражає. Що ще можна було би відзначити про компанію і безпосередньо вже так завершити наше знайомство. Компанію включено до 25 найбільших агенцій світу за версією ADH. І, власне, в 2020 році Consulting Magazine назвав EPAM Continuum однією з 20 компаній, які зростають найшвидшими темпами. Тому, власне, твердженням ще можемо ще навести декілька таких цікавих фактів підтверджень. Так, то чому ми зростаємо, чому ми ростемо? Тому що ми також присутні в загальному глобальному форматі у понад 40 країнах світу, 5 континентах. Так? Наприклад, там Північна Америка, Європа, Азія, Австралія. І, відповідно, компанію EPAM назвали найкращим роботодавцем 2021 року за версією журналу Newsweek. Крім цього, компанія впродовж останніх 3 років, наскільки я пригадую, займає провідну позицію в списку Fortune 100. І входимо в рейтинг Fortune 1000. Власне, 15 провідних компаній у сфері інформаційних технологій цього рейтингу Fortune 1000, і туди входить також компанія EPAM. Ми з вами познайомились більш детально, розповіли вам про, скажімо, загальновідомі факти про компанію EPAM. І, власне, ми хочемо продовжити наше спілкування першою нашою доповіддю, знову ж таки, з нагадування, друзі, про те, що в нас буде проходити розіграш призів. Будь ласка, активно доєднуйтесь, призи будуть цікаві. Власне, ми будемо розігрувати, зокрема, підписку на видання Ореллі. Ви знаєте, що IT-фахівці – це, як то кажуть, люди, які будуть завжди або мають завжди тримати в формі себе, так, бути фіт, відповідно до наших вимог робочих і відповідно до постійно змінних тенденцій в трендах технології в усьому світі. І, власне, якщо говорити про бізнес і літературу, джерела знань і досвіду, то одним з найкращих видавництв є видавництво Орелі, і ми, власне, співпрацюючи з ним, зокрема, рекомендуємо і будемо розігрувати підписку, власне, на книги цього видавництва серед наших учасників конференції. Нагадую, що квізи будуть стартувати і кросворди будуть стартувати у нас о 13-й годині. А до того моменту ми будемо мати доповіді, ми будемо бачити наших і чути наших доповідачів. І, власне, хотілося б задати вам ще пару запитань і почути ваші коментарі в чаті. Скажіть, будь ласка, а що вас мотивує і драйвить у вашій роботі? Таке цікаве запитання. Суботній ранок, все-таки, вихідний день, ви прийшли на конференцію, ви знайшли час, у вас є бажання. Цікаво почути про те, а що вас реально, друзі, драйвує? Так? В тому драйвує, де ваш драйв, де ваше натхнення, де ваше бажання виникає приходити і приймати участь в таких заходах. Будь ласка, напишіть ваші варіанти відповіді в коментарях. Цікаво почитати і цікаво поговорити про це. Зрозуміти вас. Так? Будь ласка. Дивимось на наш чат. Чи є бажаючі написати? Бачу, до нас доєднався Хмельницький. Прекрасно. Кава! Звісно, як в цікавій і, як то кажуть, знайомій рекламі, так? Все стартує з ідеї, але спочатку була кава. Це правда. Так, бути в тренді як і потрібним як фахівець. Так, абсолютно вірно, це є надзвичайної ваги запитання, тобто бути в тренді. Ви знаєте, якщо подивитися на статистику, так, темпу або ритму життя в 20-му, в 19 столітті, в 21 столітті, то в порівнянні з 19 і 20 століттям ритм життя, тобто кількість активностей за день, яку має покривати, моніторити, контролити людина, управляти цими активностями, вона зросла більше, ніж в 50 разів. Уявіть собі, 50 разів. Тобто ми маємо дійсно бути в тренді, і у зв'язку з тим ритм життя, зміна технологій, постійне підвищення вимог до рівня професійності, воно безумовно важливо, і воно впливає на наші, можна сказати, на потрібність наших постійно високих професійних кондицій. Тому бути в тренді, я вас дуже добре розумію. Віталій лишив коментар, він насправді дуже влучний. Хочеться зростати як професіонал в бік-дата напрямку. Так, ми про це говорили, абсолютно плюсую, тому що насправді це один з мейнстрімів 21 століття на багато-багато років вперед. Хотіння знати більше та розвиватись. Прекрасна внутрішня мотивація – це один з найважливіших чинників взагалі руху в житті людини. І, зокрема, професійний рух, він пов'язаний безпосередньо з цим бажання розвитку, це для нас все. Думаю, що ціль стати успішним через IT, побачити світ. Прекрасна ціль, насправді, так. І, власне, співпраця з, скажімо, топовими компаніями, IT-компаніями світу, вона надає цю можливість, це правда. І насправді це дуже хороша, дуже цікава ціль, тому що, як каже відома приказка, китайська, по-моєму, народна мудрість про те, що в подорож ти йдеш одним чоловіком, а вертаєшся з подорожі вже іншим. Так? І, власне, оця можливість побачити, відчути цей світ, вона, звісно, мотивує, ще раз мотивує. Робити світ кращим завдяки своїм скілам. Супер благородна ціль, благородна ідея, мотиваційний фактор. Плюсуємо знову. Це дуже-дуже круто, насправді, тому що якщо кожен з нас буде доєднуватися на своєму місці, бодай трішечки до, скажімо, суспільно корисних речей, тоді, я думаю, в усьому світі стане набагато краще і цікавіше. Нові знання, можливості, досягнення, бажання вдосконалюватися заради того, щоб бути здатним в конкурентному середовищі, залишатися актуальним та спроможним. Класно, знову ж таки, підтвердження попередніх думок. Дякую, друзі, дякую, що ви ділитесь, дякую за те, що ви проактивні, залишаємося проактивними і надалі. Ми можемо, в принципі, сказати, розповісти так, більше про нашу першу тему, нашого першого спікера. Так? Власне, давайте я пошарю екранчик, і ми подивимось на наших спікерів загалом. І, зокрема, на нашого першого спікера. На нашого першого спікера. Так? Давайте так, я оголошу, всіх будемо представляти по черзі, згідно програми нашої конференції. Але якщо подивитися на наших спікерів, це дійсно топові фахівці, і сьогодні з приємністю ми хочемо представити вам нашого першого спікера. Це Євген Савченко, це Lead Software Engineer. Він в нас буде мати дуже цікаву доповідь. Я буду говорити англійською для того, щоб уникнути цього конфузу, так, або misunderstanding нашого перекладу. Athena and Spark for Amazon EMR. Тобто, саме згадування Amazon вже говорить про те, що ця тема буде надзвичайно актуальною і цікавою, тому що Amazon, як компанія, яка провадить глобальний сервіс для побудови бізнесів своїх клієнтів, вона, звісно, знаходиться на вістрі технологій, і всі ми розуміємо і знаємо величезну кількість сертифікацій по роботі з сервісами і продуктами компанії Amazon. Будь ласка, я думаю, буде надзвичайно цікаво, корисно і, в принципі, вам має сподобатись. Наступний наш спікер, тобто я так іду просто по структурі наших спікерів, це, власне, SAFAK KAPC. В нього буде, це наш Lead Software Engineer, знову ж таки, в нього буде теж дуже цікава тема. Data in motion and new generation of DVH. Тобто, знову ж таки, сама назва Data in motion. Це є тренд, це є тенденція. Потрібно дивитися на дані, так? Дивитися на дані в динаміці, тому що динаміка розкриває суть даних, вона говорить нам про дані і так далі, і так далі. Ще наших двоє таких топових, дуже топових спікерів – це Михайло Матеєв, так? Це наш Senior Solution Architect, і в нього буде тема Data Processing with Azure, Data Factory and Cosmos. Azure, знову ж таки, як продукт, як сервіс, він дуже цікавий. І загалом основний акцент на Data Processing. Тобто, як же ж ми трансформуємо наші дані? Які є нюанси в трансформації? Тобто, які є технології, техніки, використання і так далі? Тобто, безліч запитань. Надзвичайно, знову ж таки, актуальна тема і наш топовий спікер. Один з наших спікерів, аналогічно, ALEKSEY GATSKEVYCH, він наш Senior Delivery Manager, і він нам буде говорити про Operational DataHub on Liberty Mutual. Тобто Liberty Mutual – це величезний аккаунт, величезний клієнт, дійсно величезний. І якщо ми говоримо про DataHub, то, власне, це є технологія, яка допомагає агрегувати дані, які допомагають управляти бізнесом на стратегічному рівні, зокрема, і ввести бізнес-клієнта в потрібному напрямку. Будь ласка, дивіться, слухайте, це теж дуже і дуже цікаво. Наш, як я вже казав, наш перший спікер, дозвольте представити, шарити екранчики і представити вам нашого колегу. Так, зараз. Так, ось наш перший спікер. Євген Савченко. Будь ласка, Євгене. Я думаю, можемо розпочинати.
Greetings to all. Nice to see that you have joined our conference today. And speaking of the data, there were some small things, smart and simple things, that might lead to a disaster at the end when not taken care about. And one of those we're going to speak today is data partitioning, data bucketing, basically data layout. My name is Evgen Savchenko, and I'm working with EPAM as a lead data engineer. And let's start our presentation from agenda. So I'm going to use some simplified project to go through the presentation, to go through the business problems, through the data model, through the implementations of data, speaking about the performance optimizations technique for Athena, for MR compatibilities of the Spark MR and Athena, and so on. So here's our agenda, as I spoke about it. Yeah, business problem and data model. So for simplification, let's imagine that we have several accounts or several customers, several departments of a customer, one of which is data producer, data owner, and data consumer. Also, it's responsible for ingestion. Ingestion phase is going to be from portable files to Parquet in some batches, might be 15, 10, 30 minutes. Consumption is going to be done with Spark on AWS CMR, and access pattern is for simplification. Also, it's partition 1, partition 2, for example, and then year, month, day, and hour, minutes. Metadata is going to be saved as a custom metadata on S3. Another account or accounts, they're data consumers, like major data consumers, and the consumption will going to be done with AWS Athena and Spark on AWS EMR. Yeah, Athena is a tool, AWS tool that is used for analytics and for the ad hoc queries. You may think about like Apache Hive. Under the hood, it uses Presto engine. So yeah, it's compatible with MetaStore, like Hive MetaStore. So the metadata going to be saved for the consumer as some Athena compatible MetaStore, and access pattern is year, month, day. So pretty basic one. From the business data model, we have, say, some stream of data, time stream data, which is contains some entities like event asset. You may think about some transaction in a bank, or some transaction on a stock market, some kind of bid-ask transaction. So basically the event type might be something like bid-ask update and something like this. Unit ID, it's the facility where the transaction is going. So several of them. There is like 3,000. And asset set, it's a set of the specific asset IDs and their unique one. And time as event day time, it's kind of, it's everything is for simplification purposes. From the flow perspective, you may see this, like we have some kind of abstract event ID, type ID, and for specific kind of GLD, you may think it's like gold or fuel, it's like some kind of fuel or whatever, and it goes over time, like one after one for different assets. From the relation point, event asset contains specifics, let's say assets, and event asset can be only in one asset set. Also, event asset, speaking about the unit, it can be processed only by one unit. So maybe think like the oil or gold are going only through the one stock exchange and not through another one, or like something like this. You need to asset set may vary, so different asset sets might be processed at different units. Event assets with event type relation, so yeah, it can be involved in any type of event. Speaking of types of events, yeah, some for the specific event asset, some kind of events might prevail. For another type might prevail. Yeah, from data usage point, as is mentioned, we're going to use AWS Athena, processing through the UI and processing with the API calls with the low to medium data volumes and type of queries, like most analytical based on time ground. With AWS MR, yeah, we're going to be doing like the same analytical queries with the bigger volumes and using the Jupyter notebooks and AMR UI and API calls. Yeah, for this table or like structure representation, we have a simplified like asset ID, event type ID, unit ID, event datetime, and yeah, some other columns actually present there. But still, like for simplification, we can go with such of 4 of those. Yeah, speaking next. There's some graphical representation of what's actually happening then there. What is data pipelines there? So they mentioned ingestion on one side, consumption on another side, and consumption also at the side of ingestion. Yeah, the consumption going to be done with AWS Glue Catalog. I'll mention it a bit later. And yeah, with the MR directly reading from the data bucket. Actually, Amazon EMR can use also Glue Catalog treat tables directly, like referencing the data through the tables. And from the consumption, it's going to be done by users, by SDK, with Notebook, as I already mentioned. Yeah, next, starting from my point of discussion, my point of presentation, your data layout usually shows your data interest. And I'm speaking about the querying data. So basically, you build your data storage in that format, in that partitioning, using the bucketing or whichever techniques you prefer to use. Just taking into account really like how you're going to query it, because query performance is the important part of the pipeline. So basically, you need to take care about it like really much. And the simplest approach, just to dump data in one folder. For some kind of projects, it's really suits. It's okay to have it there. Yeah, some performance issues might be when querying that. And again, speaking of performance, if you write this data and you read the whole bunch of this data, it's some kind of intermediate data that might suit. It might be okay actually for you for any kind of intermediate data. Next approach, we add some basic partitioning like here Monday. It's usually you can find it in a lot of places, like really often it's basic partitioning, but what it really shows is that you are interested in let's say date span of your data. You would like to know some specific day to read, or like some specific months or year or whatever it is. So basically, mainly you're interested in querying over data. Yeah, and next one, yeah, simplify it just to one top partition, but it can be different depending on your needs. And from this point, the interest that we show is in unit ID. So we would like to read the unit ID, and under that, maybe we will go into some months, day, or whatever. But mainly, we are speaking here, looking at this partitioning, as we are thinking about unit ID as our main point of interest. For example, or whatever partition it is, but it shows us like that okay, I would like to query the data and my main query going to be like a main query part going to be with unit ID. So I would like to go into some unit ID deeply. I'm not going to select maybe several unit IDs or like select all of them. I mean like all the data. But it is like that. Before going into deeper for AWS Athena, just global performance optimization and ideas. As we can have different type of file, there are some pros and cons about each of them. The CSV text can be easier to read, but with the issues of compression, splittability, and schema evolution, and there might be also an issue with big files when you're trying to read a big CSV compressed file. You might, face some issues with out of memory or whatever. And complex and binary data, it's harder to store there. Yeah, pretty much. Columnar, Sparky, RC. Basically, the pros are fast reads, the possibility to read like one column with predicate pushdown technique, and it's good compression, good performance, good splittability, but you need to think about your design of the schema. Yeah, and also you cannot read it like that easy with some, just some regular file reading tool, and it's not human readable also. And files are immutable, so you basically need to override them. For the row-based, the Avro, I guess it's a standard de facto for the industry. It supports schema evolution, faster serialization, deserialization. It's good actually for the binary storage, binary writes. And it has human readable schema, and it's compatible, compressible, and so on. From the cons, by itself, yeah, it's also not human readable. But file itself, you cannot read it. Just open it like a text file. Also need attention to design. Yeah, and lower performance when you try to read just a subset of columns, as it's row-based. So yeah, you have to read the whole row for that. From the point of Athena and optimizations and compatibilities, about the compatibility. So the partitioning, compression, file size optimization, columnar store, data store, optimization of partitioning, query tuning, joins, and so on. It's compatible with the Spark. It's kind of have, the tools that can be swapped. I mean, like you can use the same, take a look and find the same function as in Spark and Athena, and the simple queries that are going to be done the same way, and so on. But the bucketing, it's not really compatible there. And by bucketing, I mean the option like in Hive, when you spread your data over a file in the partition using a hash function, for example, to put specific data into specific file, with a specific column. So basically, just select the column you would like to bucket on, and the system like tool buckets it for you. To speed up the access. So bucketing with Spark and Athena, it's not compatible. And custom metadata store, it's also not compatible. For Spark, yeah, it can be used. Athena query optimizations and tools, let's say that. Yeah, federated query. With this approach, you can get an access to any other like data source. You can connect it with a JDBC connector to Athena and query from that. So you might be using some mapping for your main query, for example, to get in our project, for example, some mapping from asset ID to asset set ID or whichever. So you want to do that fast and like in not painful way. So basically, it can be done with such kind of approach and optimization. Yeah, partition projection gives you an opportunity to improve performance by basically removing the data catalog from the chain of requests. So you just saying to Athena that, hey, this data lies over there, just go and take it. Yeah, with a big number of partitions, with big numbers, it helps a lot. with a smaller number of partitions, yeah, probably you just won't get that gain on performance. And next one is bucketing with UDF. It's called bucketing, but it's a bit different technique rather than the regular bucketing. And for that, it's also a kind of a projection, but projection is done on the go, and you use a UDF, a custom built UDF, which is under the hood an AWS Lambda. And you also say, like, okay, here is the data to the UDF sent, and the UDF returns some values, you know, that you're interested in. It also might be some mapping or whichever, or some evaluated on the go mappings. And it's also gives you the, let's say, path, or like you can go to the data, store it in specific data buckets, like on specific partitions. So it can be also can be used for the, like, this is dynamic projection, let's say that. Okay, metadata approaches. For the metadata approaches, it can be used glue catalog, which is basically a Hive metastore compatible catalog. Yeah, what is good there? Yeah, it's managed for you by Athena. Yeah, it's easier to scale. You'll have to pay for the maintenance for sure from Athena side. From the other drawbacks, I can mention that can be some issues with the glue crawler. This is a tool to get the data from the storage from S3, for example, to the tables. Basically, it crawls and scans the data and puts it in the table. Yeah, sometimes it's slow, especially on the big number of partitions. For updating the glue catalog, it's suitable to use such techniques like writing your own Lambda that will go and read some metadata. For example, you're going to save metadata during the processing, and then it will read it and just add it through the API to the glue. It's faster. Yeah, also you can use external Hive metastore. The overhead here is on the development and maintenance side. Yeah, and you're responsible for everything, yeah, for scalability and so on. Yeah, it's easier to migrate. You're not tightly coupled to AWS services, so it's up to you what to choose. And custom metadata, basically really good from point of customization, but from all the maintenance and development efforts and so on, it's a bit more complex there. But it's easier to migrate. And one of the big drawbacks, let's say, or other approaches, it's not compatible with Athena for sure, and some let's say other sources, other AWS services, they might not be also compatible with it. So yeah, and with Glue, for example, you will be compatible with all of them. Okay, and moving to the data layouts. Basically, we have 5 basic overview. We have, for example, over here, event type ID as the root, year, month, day, and unit ID at the bottom. So basically, we're interested in event type ID, and as less interest in the unit ID. And so basically, we'll like to read all the data for the day rather than for unit ID. For the layout 2, we have also event type ID as a root. So basically, it's just a folder root. So that's not a partition over here. And unit ID is at the top, and other stuff is at the bottom, containing some file under the last partition. So basically, over here, we're also interested in day, in year, month, day, but more with like, you know, it is still trying to read the unit ID as a whole data for the unit ID, rather than the whole data for the date. Yeah, layout number 3, we can go for the unit ID, event type ID also as a partition, year, month, day. So yeah, interested in reading also a unit ID rather than the all other partitioning. So basically, something like this, but still with additional partition, and I will go to the pros and cons for each one. And layout number 4, it's a separate storage with a root for the event type ID, for the like separation of the event types. And another separate storage with just a, when you say just a duplication of the data by year, month, day, and day. So let's go through each of them and speak about pros and cons. Yeah, the first one, it's cost effective. It's good to query, easy to create. It fits the query patterns from Athena in our EMR. Partition is good to average. I mean, like, because we have to have this bottom partition, and as the data might be unevenly, let's say, distributed across these partitions, we may go into some issues there. Yeah, this can be high partition count there because we're still adding additional partition to the year, month, day basic one. Yeah, partial query pattern, as I mentioned, because we still kind of for one of the accounts we are fitting the query pattern. For example, we will be reading the year, month, day, and other stuff is beneath. Yeah, also this can be hours pattern, hours minutes pattern. So, but still, as optimizations, federated query using mapping can be used to speed up the readout. Yeah, it's possible to use partition projection over here. Basically, it will be okay to use it, to project some day or like some year. It will be faster to read the data. Another one, yeah, actually pros and cons almost the same. Yeah, just emphasis on the unit ID readout rather than year, month, day, basically the date one. Also, the partial query pattern as for one of the let's say accounts, it's going to be different one. So if I would like to read some day with all unit IDs, I will need to go into each unit to check like if there is a day and if there is a lot of partitions there, it might be an issue. So basically, it's also okay at some points as optimizations. Also, projection can be done to separate the unit IDs. So basically, we can go and read the data in year, month, day fashion. Yeah, it's okay to have the partition kind of layout. Yeah, next one. We have lots of partitions. This is high granularity and high partition count as a cons for this layout. It's still okay, but if you do have lots of data and if you're getting lots of partitions, more and more of new unit IDs or event type IDs gonna come, then you might be in an issue and you're trying to to crawl the data, and because of having lots of partitions, you're just stuck at this. And the crawler, glue crawler, is not really suitable for this kind of if you're gonna have like the levels of, for example, just of partitions with high partition cardinality, then yeah, might be an issue. Yeah, and for the query fit, it's also not really good from some points, but still, it's one of the layouts that might be there. Depending on your data volume and on the data distribution, it might be still okay. Layouts 4 and 5. Actually, yeah, it's good partition in there for year, month, day access. And basically, we can split the necessary data out of our, let's say, out of our main data, and faster the access, but the storage costs might be huge, depending actually of your volumes. This partition layout is also depends on your volumes, on your usage. For someone, it might be okay, but still, yeah, as optimizations from our master data, we can copy the data and basically cut out the fields that we don't need. So basically, if we don't access some columns at all for the account number 2, for example, then we don't need them. So we can just crop them, and that's fine. So maybe additional storage not going to be multiplied by 2, but less. And yeah, the chosen one. Yeah, this one that kind of was chosen for the project. There is still some issues, and the injection side because of data being not evenly distributed. We have sometimes small files issues, but still from, let's say, all of the points, it's okay. It allows us to have custom metadata, and we have a glue metadata for another account to make a cross-account access with AWS Athena. This is like kind of one of the techniques that can be used to make a cross-account access on AWS. Yeah, glue metadata is updated by separate Lambda, not to wait for the crawler to have the data as fast as possible, as much as possible real time. It's still a batch data, but you always want to have it faster. Yeah, and high partition count, unfortunately, but I believe to let's say get rid of high partition count, we need to like 2 stores with different partitions and different approaches to storing the data. Yeah, as I mentioned, small files maker, and yeah, still additional efforts for optimizations. So we optimize our Spark jobs to run over the at the ingestion point to provide better results, to be faster, and so on. So the jobs and the pipeline are always evolving. And thank you for your interest in our conference. I hope you enjoyed my presentation. Thank you and goodbye.
Yep. Thank you very much, Evgen. Evgeny, are you with us?
Yeah. Just a second.
Yes.
Yeah, please. You should be able to see me.
Yeah. Hello. Nice to see you. So thank you very much for such a significant speech. Yeah, I can say, and I think that we have a couple of questions from our colleagues. So let's switch to the first question. Why you choose Athena for your project? How about Redshift, Glue, other things, other technologies? Why Athena? Interesting question, really.
Yeah, basically, Redshift is still more like a warehousing solution, and Athena is more suitable for the ad hoc queries. Moreover, data is evolving. The schema of the data is evolving continuously. So if we are going to go into a warehouse, we still need to keep the schema as unmodified as possible, because it leads to additional effort to change to get things done properly. So, and also the price point, really significant here, because, for example, with Athena, you can go cheaper. About the speed, yeah, probably Redshift is faster here, but still, Athena is cheaper. It's cheaper even than EMR. And for some, let's say, simple queries, you can go with Athena like a lot cheaper, because, for example, the pricing for the Athena goes through the volume of the readout. So basically, if you need to scan, for example, a terabyte of data, you will pay $5 for that. But with EMR, you will pay for the spin of the cluster, like the start of the cluster, the processing, and then the shutdown of the cluster. With Redshift, you're still paying more for the storage, because like with Athena, you can just leave it on S3. Yeah, for sure. With Redshift, you can go with Redshift Spectrum, just directly access the S3 data. But in overall, let's say, needs of the business, Athena just suits better. Yeah, and it's still not a warehouse. It's closer to data lake.
Yeah, I have 2 additional questions based on your answer. Yes. So first question. For example, why you mentioned that Athena is cheaper, than other services. So please maybe you can provide some statistic information about how how much, yeah. So I mean, not just exactly budgets, but I think about times, yeah. How maybe times, or maybe some kind of percentage cheaper than 30%, 50%. How much? In general, in your opinion.
In general?
Yeah.
Yeah, it really depends on your usage, like really much, because if you would like to go with a really high volume of the data and complex queries, you will be just unable to do it with Athena. Here it's not a price point is, let's say, the issue, but the possibility actually to run those queries or those requests over the Athena. And comparing the prices, okay, for example, we have like 100 gigs of data, or like 500 gigs of the data, and at the ingestion point, and we can do this with the EMR, to process like simple processing, some compaction of the data, or with Athena. Basically, with Athena, you will pay just for 500 gigs is going to be just $2.50, and it's the time that's going to take. Definitely, it can be longer than EMR at the processing point, but overall query time, I guess, maybe on par. Sometimes really depends on the query. If you go into complex queries, the press engine that is under the hood of the Athena, it's don't like it. It likes simple queries, to some extent, of course. Yeah. And for EMR, for example, to process the same data, you need to spin several machines. Okay, let's go for 10 machines, and you pay for machine itself, for EC2. Basically, it could be something even simple. It could be like 20 cents per machine, 10 machines. You have already $2 per hour. And then you have additional price for the EMR itself, and additional overhead of price for each of the machines, like additionally inside the EMR ecosystem. So Athena is cheaper. Sometimes maybe they are on par. Depends on the usage. I'm thinking from the perspective of the project on what we have developed here.
Yes, of course. So thank you very much, Evgeny. A couple of questions from our participants. So first question: please specify your use case to use Spark for ETL jobs and AVS with EMR and with Glue. Interesting question. Do you have such experience? I think yes.
Okay. Yeah. Basically. With the Glue, you're a bit more limited with the size of a single machine, because there is only 2 types of machine available there, for the computing and for memory optimization. And sometimes with the Glue, you just didn't fit this size of the machine, and you can go into out of memory issues and so on. As for experience, the Glue is usually used for some smaller ETLs or something that's done on regular, let's say, occasions, because you don't have additional overhead of launching basically the cluster itself. So the job with the Glue, it starts immediately. It runs for some designated time. For example, we have such a system that's can kind of working like a flight recorder on a plane. We have a streaming part of the project, and some of the topics being backed up to be replayed at some point, for the troubleshooting, for debugging. As this and the Glue used to, actually the Kafka Connect is used to dump it to S3, and then Glue used for compaction. This is like kind of simple small job, runs for several minutes, once in the 5-10 minutes, and then once in a day to compact the whole data. This is really okay case for the Glue. For the EMR, for sure you have a broader variety of machines. You can go with the higher loads and so on. So as for me, it goes like only with the scale. And yeah, probably with some kind of data, like if you try to read CSV file, like a big CSV file with glue, you might not fit the memory there. So because the splitability is not good with CSV. So at least I saw that. I saw those issues there. Okay. Yeah.
Thank you very much. And one more interesting question, from Marina. So we heard about performance query optimization, but how about cost optimization? Much cheaper, we understand that. Maybe you can identify some kind of key factors that could have influence on cost optimization process with Athena usage.
With Athena, actually, cost optimizations on Athena is just how much data you read, and basically there is a let's say if you thinking about like for a project, for example, the cost optimization can be like a limitation of the maximum readout per query for a user. There is such a abstraction as a work group, so you can assign for a specific work group of your project, for example, for your data scientists, not to consume too much on Athena, just to say like, okay, we will not read more than a terabyte per time. Such instruments are there. Speaking about other, from EMR, it's a run point, because I see there's a question about like the EMR also involved there. For EMR, also it's a time. Sorry, also it is a time rather than volume. And for EMR, basically you optimize your job to run as fast as possible. This is cost optimization there. Basically, if we will try to, for example, go with weaker machines, but for a longer run, probably you will be on par. Depends on your job, but still, usually more efficient. You always want to get your data as fast as possible. So there is a reason to go with a bigger machine, a bigger cluster. Just do that in 5 minutes. The one thing that should be mentioned here is that with a bigger cluster, for sure there will be overhead because you already pay for the cluster startup. So, and basically initialization of a cluster on the EMR takes, depending on the size, but 10 minutes for sure. And you already pay for that. So maybe there is a reason for some jobs, to go with smaller cluster and longer run, but it also depends. It's like really abstract questions about cost optimizations. It's getting bespoke, regarding only to cost optimization.
Yes, agree. In general, agree. But we need to have some kind of direction of thinking, in that question. So you provide this information. Thank you very much for that. And one more tricky question from my side. How about the biggest issue that you faced with during the work with Athena, EMR, spreadsheet, glue?
With Athena, it's usually it's unavailability to run the really complex queries. We tried actually to run some complex analytics that were done with Spark and on EMR, and basically, it just fails at some time. It's when you try to process it, like the processing power of Athena is for sure not the same as the EMR. Like it's not that flexible. And the purpose of the Athena is it's an ad hoc tool for ad hoc queries. That is how it should be used. You can go into something, tweak the system and try to use it instead of Spark, but only on a kind of simple jobs. For the glue, I guess the main issues are basically limitations with the computing power still there, because it's not that capable of the EMR. And with the EMR, it's you have an issue with the EMR as far as you have issues with your Spark jobs. So if you have optimized your Spark jobs, the issue itself, like it is, I haven't seen. It's just a serverless solution for the Spark. And yeah, that's all. That's basically it is what it is. Nothing really complex. Yeah, but platform is very flexible actually. So that's my answer. Costs maybe cost with AMR because it's costly.
Yeah. Interesting answer, and I think that this answer is valuable for our participants. So, guys, you have unique chance to ask Evgeny just in live regime. Yeah, what do you want to ask? But we are waiting for new questions for you. Oh, you have. Is it possible to experience with EMR with a free tire?
Free tire. It was a long time ago that I used AWS free tire. The AWS, I think, as far as I remember, it doesn't provide you the, let's say, free tire limits you with the services. And for example, GCP, it limits you only with money. It gives you just I guess it's like $200 worth of credits, let's say that, and you can actually spin anything under this value. Yeah, but to mention that it will just vanish if you'll try to run some. I don't remember how the GCP side of service for the EMR, but still it's vanishing in a minute. So it's better not to try free tire. It's I guess. From the free tire, your option going to be to build your cluster with EC2s. And I guess it's only a couple of instances available on free tire. Yeah. Sorry, I cannot say more because it was like a long time ago.
Thank you for that. Thank you very much. So we have one more question, for you from another chat. So what was the most difficult part in the whole investigation process?
The most difficult part, basically, is usually, not always can be done at the investigation and the discovery stage. It's to get what exact usage of the data going to be, because some requirements, they appear on the go as data usage evolves, as you see some insights from it. The business can change let's say the requirements to the data, like what they want to read now, as they already find out something that is more valuable for them. This is like the prediction, which actually affects your, as I mentioned, data partitioning. So you cannot predict it like really far away. And sometimes with the data, you cannot be that flexible as larger with the services. Like you can, with a microservice, for example, you can launch another microservice, write another microservice. But if you have some master data with some partitioning and you will just want to do something else with different access patterns and your partition doesn't fit the performance, you get into trouble. Yeah, basically the way out of that, just create another view, maybe duplicate the data in the way I mentioned in the last slides for the layout number 4 or 5. I mean, like just cut out the data, bring the view on the partial view of the data, and then try to work with it. But, usually it's better to maybe apply some universal patterns at the beginning, and they work with business continuously, work on business problems, and keep in touch with them as much as possible, not to be in the bad situation at the end.
Good, thank you. And Evgeny, we want to ask you our usual question. So your 3 advices to, or your 3 main advice, for newcomers who want to work with big data.
Okay, like first advice, like know your data, know the data that you're working with, know how it's used, know how it's been should be ingested, and so on. Like the first stage that you should be doing, like always, like discovering, and as the deeper the discovery, the less issues you're gonna have later on. The second, for sure, know your stack. I mean, like tech stack. There is let's say several books the definitive guide series. There is for Kafka, for Spark, for Hadoop. Yeah, some of them a bit outdated from the perspective maybe of the latest version of Kafka or Spark, but still there gives you like very firm ground basis for your evolution as a developer, as a big data engineer, and so on. So this is the second. Read the books, read the valuable books. Let's say that.
Yes.
Yeah.
And the last one?
And the last one, yeah, try to be flexible. Still try to be flexible with the data. Try to predict. Try to use your experience as much as possible, or try to use experience from the books that you read already.
Okay, but how train your flexibility in mind, in thoughts, in actions?
I mean, be ready for changes as the data evolving continuously, as the data stack, the data like the universe evolving continuously. So you should be like ready for changes, ready to switch your tech stack, for example, from one to another for something that is faster or whatever it is. So the data layout, the data structure in this, let's say, from this point of view is really important. So you have to be flexible there too. It's like, try to go.
Yep.
For sure, you cannot guess everything, but at least you can try to be there.
Yeah, thank you very much. And I think that we have, and we have one more interesting comment from Olga. It would be great to see some benchmarks and comparison of metrics resources usage for different cases in such presentations. Okay, maybe.
Valid point for sure.
Yeah, and Olga said that thanks for the presentation. Yeah, presentation was really awesome. Thank you very much, Evgeny. And
thank you for watching.
Yes, and maybe you want to just make some placeholder. What we can think at the next steps in our conference.
Sorry, come again. But next steps in what?
In our future conference.
In our future conference.
Yes. It is some prediction or some planning. Yeah.
Some prediction and planning. Okay. Actually, the different issues and interesting points come all the time during I guess many of the projects. So I will just try to find out something, maybe in a way of current or in continuation, because still thankfully on the project I was able to work with different technologies from AWS. So yeah, for sure I will find something, maybe something Glue EMR or whatever. There is a few things. There is.
Yeah. Okay. Let's find something interesting for our colleagues. Yeah. As usual.
Yeah, I make the promise to find something interesting, not a prediction, but to be flexible, to have this flexibility point.
Yes, we need to have some jokes. Yeah, thank you very much. Thank you, Evgeny. Maybe colleagues, you have we have one more question. Did you have experience with Amazon MSK and Kinesis? Kinesis, interesting.
Okay. Sure.
What are the difference? Yeah.
The difference is actually quite a big. It's worth of presentation actually. Yeah. Okay, but making this thing short, MSK basically it's still a Kafka. It's managed for you by AWS. It has all the possibilities of the Kafka. It doesn't have the limitation of the message, because for Kinesis you have some limitation on the size, on the performance. I mean, how many messages per second is possible to get there. There is a different approach to the let's say scaling for the Kinesis, because there is a limit of how many messages per node is possible. So there are different usage. Let's say still MSK is more flexible, and say it's Kafka. So when you're saying it's Kafka, you're saying everything. It's just said by that Kafka is flexible and it can be used for in different ways. And Kinesis, it's Now, as for me, as I look for Kinesis, and Kinesis, Kinesis is just a family. There's a Kinesis firewalls, there's Kinesis streaming, and so different services for different stuff. As I mentioned, it's got lots of presentations, this comparison, but still, for me, Kafka is the flexibility, and Kinesis is you coupling with the AWS. For sure, if all of your customers, all of your business customers work with AWS or whatever, and they're like kind of okay with this stack, then Kinesis probably okay. But I want for the flexibility. Maybe for some, you have some additional effort for the setup of MSK, because it's still a Kafka. So you still need to take care about the different setup. Different phases of setup of the cluster and so on, and but it's more flexible. This is like just a brief comparison.
Yes, for sure. So, Evgeny, thank you very much one more time from all participants. Today, we're really happy that we have a lot of questions for you, and you provide really interesting answers. So thank you very much. Thank you for your speech. And
thank you.
We wish you a great day. And you, of course, I know that you are going to participate in other streams. Yes, as a listener. So see you, and thank you very much. Thank you.
Thank you. Thank you for the audience. Keep on the conference. I think everything else is going to be interesting, like more interesting than, so just keep watching. Thank you.
Bye. Thank you. Bye. So, guys, we slightly move to another speaker. Дозвольте мені представити наступного нашого спікера. Зараз, секундочку. Шарю екран. Так. Власне, наш наступний спікер, як я вже казав, також дуже досвідчений, надзвичайно досвідчений фахівець. І ми можемо передати слово SAFAK KAPC. Це наш лід software інженір, і він буде мати тему доповіді Data in Motion and New Generation of DVH. Як я вже казав, дослідження даних в динаміці, в русі – це один з таких ключових елементів роботи взагалі з будь-якими даними, і не тільки з Big Data. Тому з радістю слухаємо. Передаю слово SAFAK. Будь ласка, ми можемо починати. Дякую. SAFAK, you're welcome.
And today's topic will be about Delta Lake and structured streaming. And this is the overview of our today's discussions. We will be talking very briefly about Apache Spark. Then we will be talking about Delta Lake a lot. We will have 3 different demos. The first one will be about Delta Lake. Then we will be talking about structured streaming. After that, there will be two more demos. First one is directly related with structured streaming, and the second one is, the real-life implementation of structured streaming with a real-life data source. Then we can have the questions, but no matter what, when you have a question, you can directly ask, and I will try to answer your questions, right? I'm big data developer since 2015 and mostly focused on streaming. I am already completed more than production projects in big data. I'm a trainer for the last 5 years, and today's, as you can see, today's data set, I am a very big aviation geek, so that's why we will be using aviation data today. Let's go ahead. So I would like to start from Spark. I don't know if you already heard about it, but we have something called Apache Spark. It's a framework, and it is very fast and scalable. And almost every big data technology is working around this framework. It was Hadoop before, but now it's Spark, and right now we have several options to use it. Like we can use SQL, Spark streaming, machine learning, and anything. And the most important part why Apache Spark is very important for us is its machine learning libraries are already there and ready to use. And we can connect multiple data sources easily without any problem. And today we will be using, for example, Kafka. Okay, so let's talk about Delta Lake. Why? We already have multiple database solutions, NoSQL solutions, warehousing, and whatever, right? So basically, why do we need to have another one? This is a very good question. But the problem that most of the, let's say, new generation Delta Lakes or data warehouse doesn't support ACID operations directly. So that's why Delta Lake is quite important for us. It directly supports ACID without any issue. So what does ACID means? I believe we all aware of, but let's read. Atomicity, consistency, isolation, and durability. So basically, we will have all of them if we decided to use Delta Lake. You can ask me, okay, with Hive, that was also possible. Yes, it was, but we need to do huge amount of maintenance, and it's not so easy to use Hive tables with any frameworks except Hive. So that's why Spark guys decided to, okay, let's create another solution which connects with almost every tool in the market, and it supports ACID. But yet it has been designed for mostly Spark itself. What else? Okay, time travel. This is quite important. I don't know if you already worked with HBase, but HBase has this feature out of box by default. You just need to set the versioning, but Delta Lake, it's a default feature. You don't need to set it, and the default value will be 7 days. What it means? You can do the time travel within 7 days range. It means that you can directly, for example, you think that there was an issue with your data, and directly go back 3 days and check what has changed since during these 3 days for duration. It is open format, so basically we are using Apache Parquet under the hood, and it gives us ability to best compression in domain, in data domain, and encoding schemas are also there, right? The problem that, for example, if you decided to go with vanilla Parquet, it means that you are not going to do schema evaluation. But if you decided to go with Delta Lake, you can use schema evaluation. What does it mean? You can directly change the schema on the fly. You don't need to do extra stuff. You don't need to, I don't know, some tricks, or you don't need to recreate Parquet files. It also supports audit history. This is quite important if you are working with some enterprise companies. They always would like to see who did what. And this is possible with Delta Lake. And this is for me, this is the best part. It supports upserts and delays easily. What does upsert mean? Update, if found, update, if not found, insert. So, whenever working with NoSQL databases, update is not so easy thing, right? We need to have ACID. That's why this is quite good. Delta Lake has native support for HDFS, AWS, and Azure already. It means that you can have your data somewhere around on these locations and you can directly connect it. And this is the this graph which you see is the comparison of which one is faster and why. As you can see, this is the time versus number of partitions graph. So whenever you are using Delta, it is a lot faster, even if you don't go with the Databricks version, because there are two different versions, Databricks and Apache. So even if you go with Apache version, it will be a lot faster than Hive itself. It's time Delta Lake demo. Let's go there and let's start. I am using Zeppelin for my needs and it's quite useful. Everything installed on my localhost for presentation purposes. So I would like to start deleting with what was there before, because I'm doing huge amount of experiments, so sometimes there are leftovers and it could cause an issue. We mentioned about that Delta Lake is just actually addition to it's just a jar file, right? So if you can add, you can run it separately, but it is for run on the Spark, you need to add this dependency. It's not like an extra engine. It's a appendix to any engine which you are using. So for now, we are adding this requirement to the Spark. And then I would like to create a table. This is MD. I already added my Spark instance. And whenever I start this, it will create a range between 0. By the way, for today's program, and today's topic will be about options to use it. Like we can use SQL, Spark, streaming, machine learning, and anything. And the most important part, why Apache Spark is very important for us, is its machine learning libraries are already there and ready to use. And we can connect multiple data sources easily without any problem. And today we will be using, for example, Kafka. Okay, so let's talk about Delta Lake. Why? We already have multiple database solutions, NoSQL solutions, warehousing, and whatever, right? So basically, why do we need to have another one? This is a very good question. But the problem that most of the, let's say, new generation Delta Lakes or data warehouse doesn't support ACID operations directly. So that's why Delta Lake is quite important for us. It directly supports ACID without any issue. So what does ACID means? I believe we all aware of, but let's read. Atomicity, consistency, isolation, and durability. So basically, we will have all of them if we decided to use Delta Lake. You can ask me, okay, with Hive, that was also possible. Yes, it was, but we need to do huge amount of maintenance, and it's not so easy to use Hive tables with any frameworks except Hive. So that's why Spark guys decided to, okay, let's create another solution which connects with almost every tool in the market, and it supports ACID. But yet it has been designed for mostly Spark itself. What else? Okay, time travel. This is quite important. I don't know if you already worked with HBase, but HBase has this feature out of box by default. You just need to set the versioning, but Delta Lake, it's a default feature. You don't need to set it, and the default value will be 7 days. What it means? You can do the time travel within 7 days range. It means that you can directly, for example, you think that there was an issue with your data, you can directly go back 3 days and check what has changed since during these 3 days for duration. It is open format, so basically we are using Apache Parquet under the hood, and it gives us ability to best compression in domain, in data domain, and encoding schemas are also there, right? The problem that, for example, if you decided to go with vanilla Parquet, it means that you are not going to do schema evaluation. But if you decided to go with Delta Lake, you can use schema evaluation. What does it mean? You can directly change the schema on the fly. You don't need to do extra stuff. You don't need to, I don't know, some tricks, or you don't need to recreate files. It also supports audit history. This is quite important if you are working with some enterprise companies. They always would like to see who did what. And this is possible with Delta Lake. And this is for me, this is the best part. It supports upserts and delays easily. What does upsert mean? Update, if found, update, if not found, insert. So, whenever working with NoSQL databases, update is not so easy thing, right? We need to have ACID. That's why this is quite good. Delta Lake has native support for HDFS, AWS, and Azure already. It means that you can have your data somewhere around on these locations, and you can directly connect it. And this is this graph which you see is the comparison of which one is faster and why. As you can see, this is the time versus number of partitions graph. So whenever you are using Delta, it is a lot faster, even if you don't go with Databricks version, because there are two different versions, Databricks and Apache. So even if you go with Apache version, it will be a lot faster than Hive itself. It's time Delta Lake demo. Let's go there and let's start. I am using Zeppelin for my needs, and it's quite useful. Everything installed on my localhost for presentation purposes. So I would like to start deleting with what was there before, because I'm doing huge amount of experiments, so sometimes there are leftovers and it could cause an issue. We mentioned about that Delta Lake is just actually addition to it's just a jar file, right? So if you can run it separately, but it is for run on the Spark, you need to add this dependency. It's not like an extra engine. It's a appendix to any engine which you are using. So for now, we are adding this requirement to the Spark. And then I would like to create a table. This is MD. I already added my Spark instance. And whenever I start this, it will create a range between 0. By the way, for today's program, is a lot faster, even if you and today's topic will be about Delta Lake and structured streaming. And this is the overview of our today's discussions. We will be
Шановні колеги, учасники конференції, вибачте, будь ласка, за технічні перешкоди. Зараз ми намагаємось полагодити їх. Відпишіться, будь ласка, в чаті, чи у вас були переривання в відеозаписі, і чи нас видно і чути. Дякую.
Purposes. So I would like to start deleting with what was there before, because I'm doing huge amount of experiments, so sometimes there are leftovers and it could cause an issue. We mentioned about that Delta Lake is just actually addition to it's a just just a jar file, right? So if you can add, you can run it separately, but it is for run on the Spark, you need to add this dependency. It's not like an extra engine. It's a appendix to any engine which you are using. So for now, we are adding this requirement to the Spark. And then I would like to create a table. This is MD. I already added my Spark instance. And whenever I start this, it will create a range between 0. By the way, for today's program,
Так, колеги, я бачу, що ви написали в чаті. Так, у нас є технічні якісь проблеми. Наразі зараз наші фахівці з'ясовують, в чому питання. Переривання повтори, але зараз чутно і видно. Були і знов. Так, абсолютно вірно, були і знов. Ми просимо вас не від'єднуватись. Зараз намагаються наші технічні фахівці вирішити це запитання. Дякуємо вам за ваші коментарі, бо насправді ми розуміємо, техніка є техніка, лайвстрім є лайвстрім. І вносимо наші вибачення за технічні незручності, безумовно. Зараз їх намагаємось полагодити. Будь ласка, будьте на зв'язку. Я відразу вам повідомлю, коли ми включимось. Добре? Дякую вам. Дякуємо за розуміння. Дякую. Шановні колеги, сподіваюсь, ви за нами. Далі ця доповідь обов'язково буде. Ми трішечки мусимо, як то кажуть, вирішити наші питання технічні. Зараз ми пропонуємо до вашої уваги доповідь нашого наступного спікера. Власне, хочемо представити вам нашого Михайла Матеєва. От в нього буде тема Data Processing with Azure, Data Factory and Cosmos. Senior Solution Architect. Тому, будь ласка, просимо вашої уваги. Запускаємо дану доповідь, а доповідь SAFAK KAPC буде після неї. Добре? Дякуємо вам. Дякуємо за розуміння.
Hello everyone.
Будь ласка.
Welcome to this session about data processing with Azure Data Factory and Cosmos DB. This talk is about how we can manage and orchestrate data with Azure Data Factory and Cosmos DB, two of the most modern and effective components in Azure Data Stack. We will see how to manage different use cases and often seen scenarios with these two components and to get the best from all features offering from Azure Data Factory and Cosmos DB. My name is MIHAIL. I'm Senior Solution Architect at EPAM Systems, working more than 10 years with Azure from the beginning of first betas of Microsoft Cloud Platform. I'm also Microsoft MVP for Microsoft Azure and Data Platform and member of Microsoft Regional Director Program. I also hold PhD on cloud computing and really like to do research and to go deeper into different scenarios and work on design on different cloud solutions. What we are covering in this presentation, we will talk about Cosmos DB, the overall concept of this multi-model NoSQL database. We will go into details how to optimize this database and its performance. After that, we will discuss about Azure Data Factory and modern concept for integration between different data sources. And we will have demos where we'll demonstrate how to use in common scenarios implementations with these components. Let's start with Cosmos DB and exactly what is Cosmos DB. Cosmos DB is a modern database as a service offered from Microsoft. This service is hosted in Azure and it exposes 5 different APIs representing different data models. We have SQL Core API, the first API offered from Cosmos DB from the beginning. We have also MongoDB, Gremlin, Cassandra, and Table API. It is possible to have the same developer experience using different models and to adjust this solution to different cases in your business. That's the reason to have so many options to implement Cosmos DB into your custom solutions. With Cosmos DB, it is possible to choose the consistency model because regarding to different scenarios, you can have situations where it is much more important to have consistency, but in other situation, you need to have pretty fast update of local data into your region. That's the reason Cosmos DB to offer 5 different consistency models, from strong consistency, the bounded stateless session, consistent prefix, and eventual consistency. Choosing the right model, you can adjust the behavior of Cosmos DB between availability and consistency in the best way for your use cases. If we talk about SLA, Cosmos DB has 4 9 digits availability by default. But if you have Cosmos DB deployed in multi-regions, you can have even 5 9 digits like SLA, which is pretty significant. Let's talk about Cosmos DB design. Design of this multi-model database is pretty interesting. We have different types of models exposed from different APIs. If you have Cosmos DB core API, we have collections. In MongoDB, we have again collections like document database. If we are talking about table API, we have tables. What about if we have a graph API with Gremlin? Then we have nodes and edges. In this case, we have a variety of different components which are needed to structure your database. Because of that, in Cosmos DB, there are unified terms for components which are needed to build your account, database account. It is actually abstraction which is needed related to deployment and model which will be used as API. In one account, you can have many databases like virtual containers around data. Database is not a physical entity. Database is just approach how to structure your pieces of data in a best way for management and maintenance. Cosmos DB is using container like term, which is the main build component for your databases. That means everything which is like table, like collection will be container. And in the container, we have options to use partitioning. Partitioning is needed to scale your data. Partitions could be two types, logical and physical. Physical partitions are up to 10 gigabytes, and this is a specific setup related to backward compatibility with older versions of databases created years ago. Logical partitions can be flexible, but it is recommended logical partitions never to be bigger than physical partitions, because if you have such kind of situation, your performance will go down because of specific design and implementation of Cosmos DB. We will go back to this case later in this presentation. The smallest item in our structure is actually exactly item. We can have in containers which are partitioned items which contains the smallest piece of information. For document-based models like SQL Core API and MongoDB, this will be a document. For table API, this will be, for example, record. But to have the same approach for all APIs and to be possible to have the same developer experience and to be possible also to reuse the code which is needed to manage different models, a common term is accepted. So we have Cosmos DB account, which is mainly to specify deployment locations and API. We have databases. We have inside databases options to create many containers. Containers are partitioned, and inside containers we have items. Item is the smallest piece of information in Cosmos DB. Indexing is very important for Cosmos DB in a similar way like for relational databases. Indexing is very, very useful when you need to search fast information by specific criteria. But indexing can also kill your database performance depending on how you design it. By default, Cosmos DB is creating indexes for all items inside containers. And this approach is good when you have not often changes of your data and if you have search by different parameters. If you need to have good performance, changing more often your data, updating your data, deleting your data, adding data, in this case, you need to optimize indexes and you need to choose which options to be included in your indexes. So one of the most important things when you start to work with Cosmos DB is to configure properly indexing regarding to your use cases. Indexing is also possible to be synchronous and asynchronous. And asynchronous indexing, of course, is boosting your performance regarding to the time when you need to have solution rebuilding indexes. But if you have asynchronous indexing for some pretty new added data, it is possible to not find this data till index is rebuilt. Let's see how Cosmos DB resources are related and how exactly indexing looks. Cosmos DB account can have many databases and each database can have unlimited number of containers. In each container you are able to have a limited number of items. How you can compare different models, you can see in this schema actually items and containers are aligned to specifics which we have into different data models. But you have agnostic approach to manage this data and you are able to manage this data in a very similar way. Doesn't matter which kind of model you choose for your solution. Cosmos DB indexing works in pretty similar way how indexing works for relational databases. You have binary tree where information related to specific property is sorted and you are able to find pretty fast the exact value. You can change in any moment indexing, adding or removing indexes by specific properties. Of course, update of indexing requires time, but it is possible to be done asynchronous. It is important to know how performance is measured in Cosmos DB. There is a KPI which is related to so-named request unit. What exactly is request unit? Request unit represents processing capacity required to read single JSON document with size 1 kilobyte and consisting up to 10 unique property values. And this is what we say one request unit related to data processing. It is possible to use request units to change the throughput for your containers. And if you need more I/O, input-output operations, you can actually change this number of request units. It is possible to change the throughput programmatically or to use autopilot mode for containers. In this case, it is possible Cosmos DB to manage automatically throughput instead developers. You will need different amount of request units for different operations. Usually read is the cheapest one, where you need less request unit, but for each of next operations where you need to actually add data using post and to change data, you need more request units. And when you have querying, the number of request units depends on complexity of your query. If our containers are not in autopilot mode, we say that actually containers use provision throughput. That means maximum throughput is fixed and you can change it programmatically or via administration tools, but it is not changed dynamically from Cosmos DB. If your solution increase the data load and throughput stay close to the limit, Cosmos DB containers work in the following way for provisioned input. When you are close to the limit and even a little bit above, there is a small tolerance where actually you will not have rejected request. You will have no throttling. But if your load is continue to increase, your request will be actually rejected and you will have throttling from the server side. So your solution will need to have a retry logic. In this situation, your solution need to wait till the whole limit which is used for provision throughput for specific timeline is updated for the next hour. The smallest piece for the same provision throughput timeline is 1 hour. What you can do, you can change the throughput immediately, and in this case, your throughput will be increased, but you will pay for 1 hour for the highest throughput used during this hour. Please mind these specifics when you are managing the throughput of your containers. In the past, Cosmos DB offered collections or containers with fixed size. Nowadays, only partitioned containers are available, so you will be able to have in reality limited storage for your collections. By default, this storage is limited by 250 gigabytes, and you need to request removing of this limit or increasing this limit to have a bigger amount of data in the same container. But technically, limit is not fixed. You can increase it almost unlimitedly. There are several good practices when you have data modeling with Cosmos DB. First, it is good to recognize difference between SQL databases and NoSQL databases. And we can do the following comparison. If you have SQL database, you have all these data in the composition where different pieces of your data are organized in different containers or in different tables. When we have NoSQL, often is more effectively to have all this data in the same piece and to not make the composition and optimization regarding to similar practices which are used for relational databases. Let's see one example with menu for restaurant. We have different menu items and we have categories related to what kind of menu you have. And in relational database, it is pretty clear. You can make this in two different tables. But if we are using NoSQL with documents, this data can be mixed in different ways. It is possible to have data which is nested. For example, if we have menu, we can have items of the menu nested inside the menu objects. But it is also possible to have reference in a similar way, like when we have normalized database, where we will have different document, and in this different document we will have one object for menu and another object for items, and you can have relationships in a similar logical way like for relational databases with small specifics that here you are not able to have hard relationships on database level, but on the logical level you can build your data structure in a similar way. It is possible to make it in both ways, and it depends on what is your use case to choose the best option. If you have many different items in menus, then you can consider these items to be like separate objects, like separate documents, and if these items are repeated in different types of menu. But if you have not so often overlapping of the same items in different menus, it will be better to nest data inside the menu. Also, regarding to performance, if you need to get this data pretty fast and you will not change so often menu items, it could be better to have nested data. But if you change pretty often menu items in a specific menu, in this case, it will be better to have separate documents and to have for menu items option to edit independently these documents from this piece of data which are related to menu items. So it is quite subjective and depends on your use case what kind of approach to choose. Just in NoSQL, you have much more options to decide how to proceed with data modeling. Data modeling is also related to partitioning. Partitioning is one of the most important features to be possible to have scaling of your data. And partitioning is often transparent for your application depending on how partitioning is implemented and what exactly you are targeting with partitioning. Logical partitions are related to partition key, and you can choose partition key from the beginning to be possible to have these logical partitions in a proper way to not exceed the size of the physical partitions. In Cosmos DB, you need to remember logical partitions need to be smaller than physical partitions if you want to have good performance. If you have containers with provisioned throughput, you will have a situation where if load of data is increased, your solution can create new and new partitions automatically. Why? Because provision throughput related to partitions is fixed, but you can have more and more partitions with the same throughput, and in this way to manage increasing of the workload without changing of configuration for your containers, without programmatically to increase the throughput for your container partitions. These are different approaches how to manage Cosmos DB data depending on what kind of scenarios you have. If you mostly collect data, for example, data ingression in IoT, this approach works pretty good. If you have different scenarios where you can have queries required very high throughput, you need in any case to manage your throughput programmatically or using collections with autopilot mode. Choosing the provision throughput for collections when you have data ingression to manage the changes of workload is pretty simple. You will need to consider that when your data load is increased, you will have with specific provision throughput options to increase on steps the common throughput for your collections. And quite often solutions work in this way. Partition keys are pretty similar for different data models in Cosmos DB. So if you start work with one of APIs, you can after that reuse your knowledge pretty easy if you need to use different types of data model. The last thing about Cosmos DB, which is important, is when and how to use auto-scaling containers or containers with autopilot mode. If you are using such kind of containers, you have no need to think about the throughput. Throughput will be changed automatically. From another hand, these containers are a little bit more expensive from containers where you have provision throughput. So depending on long-term goals, you can choose to have additional effort for development and to use cheaper containers with fixed provision throughput, or to have no development effort and to use auto-scaling containers. The next important component for modern data management and integration is Azure Data Factory. We will talk about Azure Data Factory components. We will talk about what exactly we have like advantage using this service, and we will have demos where Azure Data Factory with Cosmos DB together will be used for modern pipelines. Azure Data Factory is a platform as a service component. It can be used in many different solutions, and you have no need to know on infrastructure level how this service is built and deployed. Actually, it is an integration service, and you can have extract, transform, load, or extract, load, and transform operations. Azure Data Factory is used to create pipelines where to copy and transform your data. If you need to go deeper into Azure Data Factory, I will kindly recommend to go through Microsoft documentation for Azure Data Factory and to watch some courses dedicated only to Azure Data Factory available online. Let's now see the advantages if you are using Azure Data Factory. We have from one side cost-effective and absolutely serverless data management solution. So you have no need to think about how this solution is deployed and what you have on the infrastructure level. Azure Data Factory is not expensive. You can manage data quite cheap using this component. And you can manage your data to have different data integration scenarios without need to have coding and to maintain some code base. It is possible with configuration to have most of use cases supported using Azure Data Factory. Azure Data Factory learning curve is very short, so you can have with few clicks processing, moving, transforming of data for different integration scenarios. And not in the last time, you have modeling using visual environments, so it is pretty easy to understand how exactly data integration pipelines are designed. Using Azure Data Factory, you can decrease the cost for different types of data migration. It is one of the main features where you can take advantage from this component. And you have ready-made connectors for main databases and sources, so you can pretty easy move and manage data between Azure, Amazon S3, Google Cloud, and their services related to storage and data management. With Azure Data Factory, you are paying for what you are using, so there is no hidden cost and you can optimize your expenses. Data protection is another important part of this solution. Let's now see main Azure Data Factory components. We have several components important for this service. Pipelines are probably one of the most obvious parts, which are related to sequence of activities which you need to have movement and transformation of data from one source to another one. Activities are related to single step where you can have functionalities like condition and some other parts. You can have many activities in the pipeline. Data flows are relatively new. They represent options for data transformation in pipelines, and it is possible to design this transformation visually. In reality, this transformation runs on top of data bricks in the Azure environment. Data sets are related to structure of data which is used. Linked services are related to data source connection and how we can connect to source and destination data storage. Integration runtimes are related to what kind of data you will transform and move using Azure Data Factory. If you are using local data, Azure data mix, we have different scenarios. Triggers are used to initiate execution of pipeline, and templates are reusable parts which we can actually use to optimize creation of pipelines. It is possible to use Data Factory for different environments pretty easy. All environmental parameters can be actually configured. It is possible to use it for dev, QA, prod in a very flexible way, to link data code base for your Azure Data Factory, and to make possible DevOps to use Azure Data Factory as part of their CI/CD and to deploy it whenever it is needed. Creation of pipelines is pretty simple, and you can use visual environment to design your pipelines. It is not needed to write just some code and to not have idea how the overall design is done. In pipeline, usually you have data, specific data set, which with some activities is actually manage and transform in this pipeline. You have three groups of activities: data movement activities, data transformation activities, and control activities. You can see in this schema sample Azure Data Factory pipeline where you can get some CSV file, you can add information from this file using linked service. You can copy data to another data format, and with another linked service to store this data into a table in SQL Server. As we already discussed, activities represent single unit of work or task, and we can have different group of activities regarding to categories: moving and transformation, integration, machine learning, etc. Data flows are pretty well integrated with Azure Data Factory, and you are able to use these features for data transformation without need to write code. Again, data mapping and transformation is possible to be done in visual environment. You can imagine data sets like similar objects to what you have, like tables and views, files and folders in different types of databases. Just in Azure Data Factory, the data set represents a piece of structured data. In Azure Data Factory, you have linked services to many different sources, so you have pretty high flexibility to integrate data between different sources. If you have anything specific, it is possible, of course, to consider also custom implementation. Integration runtime refers to what kind of reference infrastructure to run specific activities you need. And you have Azure runtime, where you have operations related to Azure services, self-hosted, if you have some specific things related to private networks, for example, and you have Azure SSIS if you need to proceed with SSIS packages. You have option for a variety of triggers to define when to execute your pipeline, where you can have scheduling intervals or a specific event which will initiate your pipeline execution. And of course, you can reuse your configuration using templates. And now it is time for demos. To demonstrate how can manage data with Cosmos DB and Azure Data Factory, I already created several resources. I created resource group, and inside this resource group, I added Cosmos DB account and Azure Data Factory instance. Cosmos DB account use Core SQL API, and there is one database with one container named food connection. Food group is the partition key used for this container. There is also Azure Data Factory instance, and in Azure Data Factory instance, you need to work with Azure Data Factory Studio. You can create new pipeline with choosing one of these options: ingest, orchestrate, transform data, configure SSIS. I already created, based on data injection and copying data, one pipeline. And in this pipeline, there are several settings. It is possible to rerun and debug your pipelines in context to find errors and to optimize your workloads. Let's now see how to create a new pipeline. If we choose ingest, we can choose what kind of task type we need to start. For example, built-in copy task. It is possible to have metadata, copy-driven task. Let's choose with built-in copy task. You see here different types of scheduling. Let's choose runs 1. You can choose source. Let's use for the source storage, where we have JSON file needed for our data with different information about the type of food, which will be copied into Cosmos DB. We can choose this. It is good to remove recursively, like option. You see that because of the context, we can see exactly whatever is needed for specific type of data transformation. Let's see how data looks. We have no compression. Let's choose the target type. Target type is Cosmos DB. I already created connection. And we have source destination already set up. For settings, here we have no need to make specific mapping. It is possible to enable logging. It is possible to choose fault tolerance if there's any not correct records, if it is fine to use it. And at the end, you can see how the overall pipeline exists. The last step, we have deployment of the pipeline. When we choose run once, the pipeline is run and you have this data already imported into Cosmos DB. Let's now see what we have into Cosmos DB. In Cosmos DB, we have imported data with different food groups. And you saw with several few steps, you are able to create a pipeline which imports data from storage, where we have JSON data, into Cosmos DB container. This is the most important about Azure Data Factory, Cosmos DB, and modern pipelines. Thank you very much for the attendance, and I will expect your questions.
Hello, colleagues. Again, thank you very much for your patience and our apologies for our technical problems. It is a live stream. So welcome, Mikhail. Welcome to our conference. And thank you very much for such awesome speech with a lot of examples and needed accents in our work. So we have a couple of questions for you. Yeah. First question is question from Vladislav. The next one. Yeah. Cosmos DB has APIs for MongoDB, Cassandra, Graph, etc. How are these APIs used? Please.
Thank you for the question. Can you hear me, by the way?
Yes, we can hear you well. Thank you.
Okay. So Cosmos DB is multi-model polyglot database. That means it offers API for different type of data models. Originally, Cosmos DB offered Core SQL API, which is related to examples in the presentation, but Cosmos DB also offers several more APIs. MongoDB is considered like option to shift your MongoDB applications into Azure using Cosmos DB as a database as a service. And it is really pretty easy, supporting everything from the latest MongoDB updates. About Graph API, Cassandra API, we have option to create solutions with graph data models and column-based data models. It is working without any problems. You have everything which is in documentation supported, but Graph and Cassandra data APIs are actually without analog with Azure services offered from Microsoft. For Table API, we have absolutely the same API like for Azure Storage when we are using table storage. And in this case, Table API is such kind of premium storage using Cosmos DB. That means you have different SLA and you have option to use indexing by many fields. I'm not sure if I answered the question, but all APIs are used. Core SQL API is probably more often used because it was the first API offered from Cosmos DB, and also it offers SQL syntax, which is pretty convenient for people with experience on relational databases.
Thank you very much for such detailed answer. I think that Vladislav got the answer. And if, by the way, Vladislav is with us, he provided one more question for you. Yeah. So the next question is: if Data Factory has embedded processing engine, or it is necessary to add externally Spark, for example, what else processing engines can be used? Interesting question, yeah?
Well, actually, it seems that this attendee has understanding and experience on Data Factory. Yes, Data Factory is using Spark behind the stage, but you have no need to take care on this. I mean that everything related to data processing is done out of the box, and you have no need to make anything regarding to transformations which you need to configure. If you need to call external functions for some transformations, it is possible. Just for most of the cases, it is more than enough to use what is offered from flows out of the box from Data Factory, and you have no need to know Spark, but behind the stage, it is Apache Spark. That's correct.
Okay, great. Thank you. Thank you a lot. So next question is from Maria. On your opinion, what are the weakest parts on Cosmos need to be considered on PO to switch and switch and tweet? Yeah.
Well, interesting questions, and yes, thank you for this question. In Cosmos DB, we have some sensitive configuration, and the weakest part is probably to have the right understanding how to optimize the solution regarding to the cost and to the performance. One of the most often seen mistakes is when you are using Cosmos DB with default settings. Default settings are related to indexing by all fields. Indexing by all fields offers relatively flexible search, but operations related to update and insert are much more consuming, because indexes need to be rebuilt asynchronously behind the stage. So configuration is not so complex, but initially, when you start to work with Cosmos DB, you need to think about configuration. Default configuration is configuration which allow you to prototype something, but in most of cases is not very suitable for production. And probably this is the weakest part, because people need to think about this. Quite often it is not clearly explained, and impression is that Cosmos DB does not perform as it is expected.
Yeah, thank you a lot. I think that you provided the whole answer, yeah, complex answer to this question. And the next one is question from Olga. So what kind of major issues you'd face while loading data into Cosmos DB with ADF?
Well, with ADF, when we are loading data to Cosmos DB, in general, it is mostly related to how we can configure our pipes in Azure Data Factory. So it is up to Azure Data Factory in general how we will insert our data. What probably is sometimes issue is that Azure Data Factory also is working asynchronously. It is not expected to have such kind of consistency if in the source something is changed immediately to have these updates in the destination storage. So if you expect such kind of behavior, probably it will be challenging. If you need to have consistency, probably need to think about direct options to update Cosmos DB.
Yeah, thank you a lot. And additional question from us, yes. So your best 3 advices that you can provide to guys who wants to work with big data. Yeah.
Okay, thank you for these questions. First is no one really understand from the beginning everything related to data models and how to process big data. So be patient and go deeper into technology and theory. It is just a slightly different way of thinking. So don't relate managing and maintenance and analytics on huge amount of data as something which is the same like if you have operational databases. And you need to learn a little bit more about different approaches. You need to know a little bit more about statistics. By the way, statistics is something which I will put like my second recommendation, because most of theory related to big data is related to statistics. So please get familiar, not probably in details, but as overview with some main statistical approaches and foundations, because it will help a lot. Usually in big data, we do not look for exact answer. We quite often have some estimations, we have predictions, and it is a different way of thinking. And probably the third one is don't relate big data to any specific technology stack. Doesn't matter how you are using solutions with analytics on big data solutions. The things are common. Technology is just a tool. So think more globally, cross-platform. Don't think that, for example, Python or specific language is exactly what you need for big data. The most important is to achieve the appropriate mindset and to have a little bit more understanding about foundation and theory for big data and statistics. It was not with 2 words, because it is not easy to explain it with 2 words, but hope that it is understandable.
Yeah, thank you very much. And you know that I totally agree with you, because from our vision depends everything. Yeah. So we need to build this vision step by step. And by the way, what kind of maybe books about architecture you can recommend to our participants? Maybe a couple of them, your best choice.
Well, it depends on what kind of architecture. It is probably very difficult choice because considering different type of solutions, we need to think about different types of books. So it is quite difficult to recommend something in a specific domain. We have some books for solution architecture, different books for data analytics. If we consider people from our region, because worldwide there are a lot of things, but in Central Eastern Europe, I can recommend one author. His name is Marcin Zeliga, and he's from Poland. Please check his books. This is a very typical example of person who is very good in database administration and development with relational databases, and he spent many years to change his focus from relational databases and DBA to big data. So probably for most of us, like engineers, this will be something very similar. So he wrote several books. You can just check in internet about himself. I really recommend him because he's one of the best, at least in the region, from my point of view.
Yeah, thank you so much, Mihail. I think we're good with our questions. And thank you for such amazing talk. And I know that you're going to participate here in other streams as well. So thank you a lot, and we can switch to another speaker. Thank you, Mihail. Have a great day.
Thank you very much, and have a nice day.
Thank you. So, colleagues, we can switch again and come back to our previous speaker. So, again, let me show my screen and present the next speaker. Yeah. So we going to from MIHAIL MATEEV. We're going to our SAFAK KAPC. So again, data in motion and new generation of DVH. Please, SAFAK, you're welcome, and we can start.
And today's topic will be about Delta Lake and structured streaming. And this is the overview of our today's discussions. We will be talking very briefly about Apache Spark. Then we will be talking about Delta Lake a lot. We will have 3 different demos. The first one will be about Delta Lake. Then we will be talking about structured streaming. After that, there will be 2 more demos. First one is directly related with structured streaming, and the second one is, the real-life implementation of structured streaming with a real-life data source. Then we can have the questions, but no matter what, when you have a question, you can directly ask, and I will try to answer your questions, right? I'm big data developer since 2015, and mostly focused on streaming. I am already completed more than production projects in big data. I'm a trainer for the last 5 years, and today's, as you can see, today's data set, I am a very big aviation geek, so that's why we will be using aviation data today. Let's go ahead. So I would like to start from Spark. I don't know if you already heard about it, but we have something called Apache Spark. It's a framework, and it is very fast and scalable. And almost every big data technology is working around this framework. It was Hadoop before, but now it's Spark, and right now we have several options to use it. Like we can use SQL, Spark streaming, machine learning, and anything. And the most important part why Apache Spark is very important for us is its machine learning libraries are already there and ready to use. And we can connect multiple data sources easily without any problem. And today we will be using, for example, Kafka. Okay, so let's talk about Delta Lake. Why? We already have multiple database solutions, NoSQL solutions, warehousing, and whatever, right? So basically, why do we need to have another one? This is a very good question. But the problem that most of the, let's say, new generation Delta Lakes or data warehouse doesn't support ACID operations directly. So that's why Delta Lake is quite important for us. It directly supports ACID without any issue. So what does ACID means? I believe we all aware of, but let's read. Atomicity, consistency, isolation, and durability. So basically we will have all of them if we decided to use Delta Lake. You can ask me, okay, with Hive, that was also possible. Yes, it was, but we need to do huge amount of maintenance, and it's not so easy to use Hive tables with any frameworks except Hive. So that's why Spark guys decided to, okay, let's create another solution which connects with almost every tool in the market, and it supports ACID. But yet it has been designed for mostly Spark itself. What else? Okay, time travel. This is quite important. I don't know if you already work with HBase, but HBase has this feature out of box by default. You just need to set the versioning, but Delta Lake, it's a default feature. You don't need to set it, and the default value will be 7 days. What it means? You can do the time travel within 7 days range. It means that you can directly, for example, you think that there was an issue with your data, you can directly go back 3 days and check what has changed since during these 3 days for duration. It is open format, so basically we are using Apache Parquet under the hood, and it gives us ability to best compression in domain, in data domain, and encoding schemas are also there, right? The problem that, for example, if you decided to go with vanilla Parquet, it means that you are not going to do schema evaluation. But if you decided to go with Delta Lake, you can use schema evaluation. What does it mean? You can directly change the schema on the fly. You don't need to do extra stuff. You don't need to, I don't know, some tricks, or you don't need to recreate files. It also supports audit history. This is quite important if you are working with some enterprise companies. They always would like to see who did what. And this is possible with Delta Lake. And this is for me, this is the best part. It supports upserts and delays easily. What does upsert mean? Update, if found, update, if not found, insert. So, whenever working with NoSQL databases, update is not so easy thing, right? We need to have ACID. That's why this is quite good. Delta Lake has native support for HDFS, AWS, and Azure already. It means that you can have your data somewhere around on these locations, and you can directly connect it. And this is this graph which you see is the comparison of which one is faster and why. As you can see, this is the time versus number of partitions graph. So whenever you are using Delta, it is a lot faster, even if you don't go with Databricks version, because there are two different versions, Databricks and Apache. So even it will be a lot faster than Hive itself. It's time Delta Lake demo. Let's go there and let's start. I am using Zeppelin for my needs, and it's quite useful. Everything installed on my localhost for presentation purposes. So I would like to start deleting with what was there before, because I'm doing huge amount of experiments, so sometimes there are leftovers and it could cause an issue. We mentioned about that Delta Lake is just actually addition to it's a just a jar file, right? So if you can add, you can run it separately, but it is for run on the Spark, you need to add this dependency. It's not like an extra engine. It's a appendix to any engine which you are using. So for now, we are adding this requirement to the Spark. And then I would like to create a table. This is MD. I already added my Spark instance. And whenever I start this, it will create a range between 0. By the way, for today's purposes, demo purposes, I am using Python. I am going to write it to this table. That's all, simple. As you can see, I created a range between 0 and 5, and I write to a table. Let's try to read it if it is really there. And whenever I do that, as you can see, it has read from this location and show it to us. Simple, easy. And I would like to override it. Is that possible? Yes, it is possible. It didn't complain about anything. So the same table, and on the first run we put 0 to 5, then in the second run we put 5 to 10. Perfect, yeah, it is working. So let's try some extra operations like some update, then delete, then the upsert itself. So updates, we are going to only do, if it is divisible by 2, we will add 100, right? Then delete condition, if it is divisible by 2, we will delete those records. Then we will create a new data set, and we will try to, as you can see, merge condition, when it's not found, it will be sorted. So let's execute. Each operation will be done in this order: update, delete, and the merge. So that's perfect, right? It's working. And as you can see, we added somewhere like 100, right? But now they are gone because then we have deleted it. So the question is that, are we able to see these records? Let's try. As you remember, I said that we have option to do time travel. So basically, I would like to see first version. What was it? As you can see, it was 0 to 5. Then the first version, the second actually, right? There are some records. Let's continue. Let's go ahead. Okay. Yes, if there's a question, please ask. And as you can see, we can do the time travel with each operation. And this is important. Why? Because let's assume that you have machine learning application, right? And 4 days ago, you have predicted something else for someone. And today, your prediction has been changed a lot. And you need to see what has changed. Or you are just testing a model over time, let's say. So you need to see each iteration of these data to see how your machine learning algorithm is working. Okay, so I know structured streaming is our next chapter, but let's try to create something, some data, continuous data for our delta table. We have something called rate, so it will creating numbers for us, and we will stream it to our table. Let's see. Right now, okay, and perfect. Now I started my streaming, and as you can see, we already produced some numbers. I just want to see how it is growing. Yes, it is growing. We are adding extra numbers. That's perfect. I would like to stop these streaming parts. Okay, one thing which I need to explain. The first one is just a rate generator. It means that we are just creating a random stream and saving it to delta table, which is supported. So basically, from structured streaming, you can save it to delta table. This is quite important. And the second part is we are reading from delta table in manner of streaming. So basically, whenever there is a record, it triggers our streaming stuff and it updates our table. This is quite important. So let's see the history. So we did huge amount of changes. Right now there are 21 different versions, right? Actually 22 because it's starting from 0. So basically the last one is streaming update because we have tried to insert new records from the streaming. Let's go to very beginning. The first one was write. We write directly, we wrote it, right? Then there's an update, there's a delete, and the best part is about to come. As you can see, this is a merge directly because we call a merge operation on top of this table, and it is recorded as a merge operation. Parquet files, and okay, so who's keep tracking what's going on inside of these Parquet files? There's a folder called delta log, and let's go inside of this delta log. This delta log, as you can see, has JSON files. Okay, so what is it inside of this JSON? Let's start with version 0. These JSON files, by the way, exactly match with your version count. So if we have 21 versions, it means that you will see 21 JSON files. And with which in every JSON file, you will see affected Parquet files, the types, the changes, what happened, who did it, and so on. So this is for example, the first version. Let's check the third one. I believe merge should be the third one. No, this is delete operation, then the merge operation. As you can see, it describes that this is the version check because the JSON version for the merge. And these are the operation parameters. So basically, if old data equals to new data, matched, and so on. So, and also you see how many files has been affected because of this change. And let's try to read this table as Parquet. And as you can see, guys, we are able to read some data. Yes, perfect. So this is created due to failsafe. So if something goes wrong, you can directly read from Parquet table. And now I would like to test something else. We discussed that schema evaluation is supported, right? So how is it happening? Let's try to add literal. So basically I will try to add 10 and I will save it to our table, right? So oops, I did something wrong. Okay, what I have done? Actually nothing. It's perfectly fine. It is angry with us because something is not supported. Let's retry. The missing part is, as you can see, guys, it's already told us. This one doesn't work because schema mismatch is detected. But everybody told us that Delta supports this option, right? It should do the schema evaluation without our support. But this is also here fail-safe operation. I mean, if you really meant to change the schema, you need to add this option to your query because you need to there's no confirm button, right? Please confirm. You need to add this option to your query to append to make changes on. Let's rerun it. As you can see, it said that, okay, I did it perfectly. That's great. So let's try to read one more time. As you can see, guys, we just managed to add new value for all records. But from now on, if I try to read through Parquet, like I did in the in 3 or 4, yeah, in here, it will fail because schema has changed. So basically, there will be multiple schemas for Parquet files. That's why this is good and bad at the same time. And streaming, let's start from the previous one. This is old good Spark streaming. It is working as micro batches, right? So basically, it arrives to us, we are waiting for the duration, then we do the processing and we uploaded the locations, or we just do the processing and send back it to Kafka or something like that. So basically for this Spark streaming, we have huge amount of APIs. It's on the market since, I don't know, 2016, something like that. So this is quite old, bulletproof, and we know that this is a working one. But there's a one big but with this Spark streaming. Like I said, it is working in micro batches mode. So whenever you would like to do some fancy, some more interesting, let's say, thing, you need to be coding wizard. I mean, you really need to be magician to do some stuff. That's why Spark guys thought that maybe they should have another approach, which is called structured streaming. So what is the difference between structured streaming and Spark streaming? So structured streaming is a continuous processing. Basically, the data arrives to us directly to our unbounded table. It is called unbounded table. Our data arrives in this table, and it is already ready to be processed immediately. And this system ensures like end-to-end exactly once fault tolerant guarantees through checkpointing and write-ahead blocks. Some of those features were there Spark streaming, but for example, exactly once one of the challenging thing. Now this problem has been solved, and every data item is arriving on the stream is like new row. So basically, you can think that we are having one big table, and every new record inserting to the end of this table. So let's think about a use case. So we have 3 time positions, T1, T2, and T3, right? Within T1, there will be a result, then the output, because the query is always there. It could be select star, or it could be some aggregation or whatever. It is always there, and it is doing the process after you put your input table. For example, in this picture, it's derived as some aggregation operation, because the input table is growing, but the result and output is the same. So for structured streaming, we have 3 output modes: complete mode, append mode, update mode. Complete mode means that you will be getting every result which is written to your input table. So that's like doing select star. Append mode is just appending new records, or doing something, adding to new records. And update, the quite same with append. If the record is there, it is updating. If it's not there, it is appending. Okay, so there's one thing: complete mode only works with aggregations. So it means that you need to have some aggregation like group by or something like that, because it could be very, very big, and it could end up very, very badly for your memory, because this table, this unbounded table, stored in your memory. So if you go above your memory, there will be some spillover to your disk, and it will cause a lot of issues. Okay, let's continue. This is another good example which we are going to do in our demo. So basically, the word count on structured streaming. For example, at T1 we are getting 4 words. At T2 we are getting 2 more words, and at T3 we are getting 2 more words as well. As you can see, in the first iteration, our unbounded table has 2, then it's going up, and at T3 we are having all records. This is still our unbounded table, and it's coming end to the table. Then word count query. It is doing the query on top of what we have delivered, what we have given to our processing engine, and it's working on our input or unbounded table. Then there's a result table. So basically, our result table is like cat1, doc3 for first iteration. Then for second iteration, cat2, doc3, and ov1. So perfect. Everything looks great. And like I said, this is complete mode. So it's not gonna work with, with if you are trying to get all records. If you are trying to get all records, it should be append or update mode, right? Okay, and today we have directly 4 built-in sources. It could be file source. So basically I showed like from Delta Lake. It could be Kafka source. This is the more circuit source, which I will show it to you very soon. But this is only for testing purposes, so please do not try to use it in production. And RAID source, the same story, only for testing. It generates number, and it shows that if your application is working or not. Okay, so this is how our table looks like. We are getting the records. This is window grouped aggregation with 10-minute windows and sliding every 5 minutes. So basically we are adding something new. It means that we will have our result table for last 10 minutes and we will do the processing with every 5 minutes. Well, this is important because of why? Because you may think that we need to have, for example, we need to have data for 7 days, like historical data, and we need to calculate sales on a daily basis at midnight. So it means that you need to have last 24 hours of data to calculate, and you need to have last summary to make the to make this comparison. And then it will be our function will be like 7 days windows and sliding every 1 day. So this is exactly the same story in here. We are moving the window every 5 minutes. So basically once we reach the 12:15, we will be having only data from 12:05 and we will be doing this calculation. Okay, watermarking. Yes, this is quite important when you are working with window of operations, because watermarking guarantees that what you are going to do with late arriving data. For example, in one of my previous projects, we were getting some data from SCADA systems from their right, and there are some issues with installation or something, and 3 days for 3 days system was down. So basically we had to wait 3 days. Then after 3 days they're plugging into the grid again, and you start to get data from this wind turbine. But if you calculate data, then it will mess up your, because everything comes in one place, one big batch, and it will create huge disturbance. So that's watermarking. It guarantees that whenever you have data, late arriving data, it won't be processed. So you can specify this time window. For example, in here, it is 10-minute window. So if you get a record after this window has been closed, let's say, data will be ignored, right? But arriving data still within window, it will be calculated, and it's up to you decide which window you should take it. We are getting the doc at which has been created at 12:08, but we are getting this record around 12:16 or 12:17, so it will be calculated. The same story for all at which arrived to us 12:13. Sorry, not 12:13, almost 12:20, but it has been produced at 12:13. So basically these data points will be calculated, but Donkey, which has arrived 12:22, 12:23 maybe, it is very late for us and it's not going to affect our calculation. So that's why watermarking is quite important for us, and once there's an issue, you just need to it shouldn't affect your calculations, right? It should be ignored, like anomaly or some streaming demo. Let's start. As guys, there will be some first. So this is directly from documentation, so it is very good and very useful. Oops, give me a sec. I need to run some example on socket. Need to have socket up and running, and I will show it to you how it looks like in our system. Let's go and let's run it. So basically I just open a port like 9999, and we will be getting data from this port. Our structured streaming. So basically we need to define what we are, as I mentioned before, we need to have a query. It could be even select star, but it should be something. Then in first options we are defining what we are going to listen, the host and the port. Then we are giving the query. So basically whenever there's a line from our example, we are doing a flat map operation, and we will do a group by. So once I run this cell, the structured streaming is not up and ready yet, because it requires this keyword, start. We need to have this start keyword, and we need to give, this is not a requirement, but it helps a lot to organize your structured streamings, as name, and I am specifying the location. My format is memory. It could be delta as well, but in this example it will be memory. And as you remember, complete mode. We are going to use complete mode because we already have our group by. So let's try to start. Then it's reported to us that, okay, something is up and running. Let's go our Spark dashboard, Spark UI, to see that if something is really up and running. As you can see, guys, whenever I am inside of this UI 4040, maybe not 4040, it could be 4041. It is there. Yes. Let's try to click structured streaming. So as you can see, word counts is up and running. I have another one which I will show it to you very soon. But let's go this word count example. This is our run ID. Sorry about that. That it's running for 41 seconds, and input rate is 0. Batch duration is almost 0 because there is no record arriving. Let's try to produce some messages. Let's do like cat, dog, 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 up, dog, yes. And let's do all dog, right? So basically we sent some messages. Let's see if we are going to get them. Yeah, we are getting some messages. Perfect. Let's try to query it. And as you can see, guys, I just defined a query name in here, and I am going to use it like I'm typing in SQL, select star from word counts, order by count ascending. Yes, that's true. I am seeing some messages. I can even do a pie chart. Cat, dog, all. Let's try to create some anomaly, and let's put another word. Let's try to put test. I don't know, 1, 2, 3, whatever, EPAM, right? And let's try to see it in our stuff, if it's going to come here or not. Sorry. As you remember, this table is in memory right now. So I am going to stop this streaming. So there's no streaming anymore. The question that am I able to query this table or not? Because I just killed the streaming. The answer is yes, we are still able to query because this data has been already loaded. Until next restart of Spark Core, it will be there and you can use it your own purposes, which is quite useful. Okay, the best part of the working with real life data, I am going to use something called state vectors. This is directly related with aviation data. we are going to get this data from OpenSky network, which is, like the name suggests, it's open data for aviation geeks. It's like Flight Radar 24, but it's not paid version. There's a API which we can get it, we can use it perfectly and without any issue. Right now it's up and running. We will consume some messages, some real life messages from this API. Let's try. So basically there's something specific called state vectors inside of this APIs. These state vectors give us almost every detail about the airplanes which are flying right now on the world, almost every plane. And this data set has ICO. This is unique thing for every plane: call sign, country, last contact, latitude, longitude, altitude, and velocity. They are quite important information for us. And we are going to get this data. We are going to get this data from a Kafka server. As you can see, our source is Kafka. So who is providing these messages to Kafka? I have a working application. As you can see, this is this is using OpenSky API directly from their website. I am getting it and I am sending it to my local host. Very, as you can see, just get the message and done. Okay, so let's go and let's see how it looks like in our Kafka. So basically, I am going to create a console consumer, but this is the data format. As you can see, this is pushed by my Python application to our Kafka, and this is the topic which we are listening. So let's try to read this Kafka topic from our structured streaming. I just defined a schema because whenever I'm working with schema, it's very useful, and the thing that each message is one line of JSON. So it's not very useful for me unless I'm not sending it to, some kind of NoSQL database like MongoDB. So basically, I need to colonize it, let's say. So that's why I convert everything to string, and there's a from JSON function. And once I run it, it will dump whole data from this Kafka topic to us. And it will be in memory, but it will be in append format because there's no aggregation. I will try to get everything directly. And there's one thing, as you can see, I am triggering with every 10 seconds. It means that there's a continuous streaming, but for this example, I would like to use manually triggered operation. It means that with every 10 seconds, it will go there, try to read it, and if there's any messages, it will process. So let's try to read it. There's already some records. Let's check how it is looking from our streaming UI. So let me check the name. It's called query2. As you can see, there's query2. Let's go there. It's working for just 30 seconds. And let's go how many messages we are getting. We already get almost 800 messages per second. And we are able to process these messages, which is everything cool. So there's no issue, right? So let's try to see one more time. Yeah, it is working. So, but this is not useful for me. I'm not getting anything from this one. So basically, I want to stop it. I saw that, yes, data is coming to us, but I would like to do something. Like, for example, I would like to calculate how many planes coming from which country, right? So basically, as you can see, this is direct equivalent of group by statement in Scala. This is some kind of known issue on Spark 301. So basically, yes. Right now I have used start and the query name, so basically query 3, but this is, as you can see, complete mode. It means that there's an aggregation, which is there. we are grouping by and counting. Let's try to see how many airplanes we have from which country. Right now the answer is 0. Why it is 0? Let's go and let's check our structured streaming. Query 3 is running for 28 seconds, as you can see, guys, and still it didn't pick up any messages yet, so basically we need to wait a little bit while it is trying to read something. Come on. Still 0, still it didn't pick up any messages. This is something. Query 3 is up and running. 1 minute, 1 second. There should be, yes. Now we are started to get some messages. Let's retry to count it. As you can see, we have 5,900 planes. And I would like to do select star. It was to count for everything, and as you can see, we are having these planes from these countries while they are flying. And within time, it will be increased because I grouped by ICO and country. So we know that which one has what. And now I would like to group by origin country. Okay, perfect. We are getting most planes from United States, then United Kingdom, China, Germany, Canada, Turkey, India, France, and Emirates, and so on. So basically this is how it has been calculated in time. Okay, we solved that something is running, right? But we didn't solve any real life issue. So basically, if I am, let's assume that I am an engineer who would like to solve issues with our airplanes. So how should I do that? Let me stop this writer first, because I will be running again. Yes, everything is finished. So in this one, I will create a data frame. I will give a schema. Again, the same story. I will do the casting, perfect, fine. But now, in this example, I will convert it to dataset. There's one difference with data frame and dataset. So in this example, I will create as a dataset, and it is there. But nothing has been started yet. What we have defined, we will be getting data from Kafka, we will be subscribing to this topic, and this is our schema. Then at the end, we are converting it to dataset. Okay, let's try to make it real. But then I'm not going to make it for 20 seconds. I will make it for 10 seconds. Again, I am triggering it via trigger manually. It will be append because I am getting all records and I am setting starting offset. So what does it mean? I can set the beginning. So basically it will try to get messages from the very, very beginning. And in here, I don't want to do that. I just want to start the streaming from the latest. And as you can see, guys, I named my query as query. So I can directly use it in SQL. And the response is 0, but the schema is already there because we defined. So let's try to get it. It is running for 15 seconds. And there's still no batches. Okay, perfect. Let's wait another 5 to 10 seconds. It should arrive. Something should arrive to us very soon. While we are waiting, we can continue. I cannot because the next example also requires counting and grouping. So please arrive something. Yes, we started to get messages. Perfect. Something is weird. Some records are getting nulls. It shouldn't be happening, but I don't have any data quality check on top of this system yet. So basically, that's why it's going to happen. And now I would like to just make a count to see, oops, sorry guys, how many messages I got from airplanes, right? For example, right now I am getting 4 messages from this airplane. Okay, let's see, where is it? I can do something like that. I am putting ICO And guys, as you can see, I have created a map on top of this data, and I know where it is displaying, where it is and how it is flying. It is directly inside of Atlanta. So as a domain expert, I know that there are some critical codes for us, right? Like 7500 is hijacking, 76 each. Okay, let me start from that part. Each airplane should assign a transponder code, and there are 3 critical transponder codes which should never be used unless it is required, like hijacking for 7500, radio failure for 7600, and general emergency 7700. So it means that if we see some messages like with these 3 SCAF codes, we have bird which is in emergency. So basically, yes, we are getting messages. This is directly real life message. So, oops, sorry guys, my bad, I couldn't copy. Okay, so let's run it and let's see where this bird is. As you can see, it is Madison. So I would like to do also one more thing. This is, yes, we see this airplane somewhere, but is it real? Let's check. And right now it is searching for this one, and it says that it is somewhere. It is here live. So let's click, and we are able to see this airplane is really up alive there, and it is sending emergency messages. Okay, interesting. Let's go ahead. So basically we know that which airplanes has an issue right now, and we mentioned that we can use Delta as a target. So let's check that if we have running structure streaming. No, there's 0. So let's try to write this data directly to our table, and I have just started. As you can see, I defined a format Delta. Before we were using format memory, and right now we are using format Delta, and output mode is append because we are typing everything, we are writing everything. We don't need to do any group by or any aggregation. We just need to have raw data. And let's see, as you can see, SkyStream Writer is up and running, and it is even getting some messages. Perfect, yay. So let's go ahead and let's load it directly from this location instead of reading from structured streaming. Okay, and by the way, this has been running for several hours, so we have a lot of messages like, okay, more than 2 million. This is great. And let's run the same query to check if there's ongoing stuff. As you can see, guys, at the same time, we are writing through structure streaming to our system, our Delta table, and we are reading it. So as you can see, we have some messages back then. Oh, interesting. Even we got hijacking messages 2-3 times. Probably somebody is testing something, but let's see where they are, because the hijacking message is the most interesting one for me, because is somebody really hijacking or somebody is doing a test? Okay, this plane was flying over Panama. Interesting, maybe it was real, I don't know. Okay, so the last example is to write to my memory everything. I can read a Delta table in streaming manner, but if I try to read this 2.5 million records into my memory, it always dies. I have tested, so I'm not going to run it, but it is possible. And yes, this is the end of my presentation. Any question, guys? Anything? Any comments?
Hello.
Hello.
Yes, nice to meet you. Thank you very much for such detailed presentation. Really interesting things you highlighted there. So, yeah, colleagues, we have the great ability to ask SAFAK all questions that you are interested in. Let's do that. And what do we have in our chat? So we have a couple of questions here. And in our chat, we also have a couple of questions. So this is great. From Vladislav. Is Spark installed locally in your PC to run Zeppelin notebook?
Actually, no, it's not. It's not necessary to run Spark locally because Zeppelin has already version which you can run directly without any troubles, whatever. But also it has an option to just specify another Spark location. It could be on your local machine or it could be some cluster.
Great. And one more question from Vladislav: how use Delta Lake in AWS? Is it necessary to use EMR cluster or S3 buckets are enough?
Okay, so basically, like I described in this presentation, data lake tables are just Parquet files. So wherever Parquet files are supported, it's perfect fine. So for example, you can put it on S3, yes, and the metadata management will be covered by the Delta Lake itself.
Great. Thank you very much. And one more question from Alexander. What about scheme evolution and the need to maintain separate environments for dev, QA, and prod? With traditional DB, we versioned scheme and did migrations. Yeah, Delta Lake does not have tools for this.
Delta Lake is still immature tool. Yes, it is still missing some some advanced capabilities like moving something from test environment to prod environment, for example. This is still in progress, work in progress. They are still trying to develop, but in some manner, for example, you can have custom third-party tools, which is literally based on these approaches. For example, Flybase scripts could help you a lot to make these migrations automatically. Still, you will have the power of versions both through Flybase scripts and Delta Lake tables.
Thank you. And two more questions. Why are you choosing streaming as the most interested area to focus on?
Okay, so because whenever you are doing you are processing the streaming data, it means that you are touching the live data. I mean, there is no rolling back. There is no it's more adventurous for me, I would say. That's why I feel adrenaline.
Yeah, great. And one more question. Based on your presentation, we've seen past and present of data streaming concepts. How do you think can look the future of it?
Okay, so the problem that we do not have one basic definition for streaming, right? It's usually up to project. For example, for some projects, you need to have very, very eager real-time processing. I mean, for example, let's assume that you have a Tesla car and you need to understand when you are going to maintain your car. So it means that you need to have very eager, very, very advanced streaming process, and streaming process should be doing line-by-line processing. But also, on the other hand, let's assume that you are an oil gas plant and you would like to check what happened for last week, for example, if there's a corrosion or not. So in that manner, it requires batch operation instead of row-by-row operations. So from my perspective, we will be using both, and we will see a lot of advancements on both processing mechanism.
Yeah, thank you. And I think that I think that's all about questions from our colleagues and participants. And traditional question from us, what your three advices, best advices to the people, to guys who wants to work with big data?
So first of all, they need to get ready to read the logs, because big data development is mostly about reading the logs. The second one, I can say that persistency. They should be very persistent, because so far I have seen that out of 100 people, only 10% 10 people could become big data developer, because most of the people just got bored and just overwhelmed due to workload. So the second one is persistence, and third one, learning every day. So we should be everyday learners, and we should continuously improve ourselves, because in big data domain we have more than 100 tools, only one landscape. So it's impossible to learn everything, but at least we should try to understand what we are doing and why we are doing.
Yeah, you're right. I totally agree with you, because a little progress every day adds up to big results. Yeah, something like that. So, one more question from our colleagues. Why are you choosing streaming as the most interested area? Yeah, we have this question.
Yeah.
Just duplication. So, thank you very much, SAFAK.
Thank you so much
for your participation, for your very interesting speech, and have a great day.
You too. Yeah. Bye.
See you. Bye. І так, колеги, прийшов час для наших квізів, так? І давайте нагадаємо нам порядок роботи з квізами, так? Ну, перш за все, в нас буде 3 квіза в нашій групі, і буде розігруватися 3 підписки на Орелі. Ну, згідно наших, як то кажуть, попередніх планів і домовленостей з вами. Я думаю, що зараз наші колеги з саппорту пошарять лінк в чаті і публікують в YouTube-каналі. Лінки для наших квізів. На кожен квіз, друзі, відводиться по 3 хвилини. Ми будемо, як то кажуть, засікати таймер. І, власне, переможців квізів буде визначати система, так? Результати будуть надіслані всім, так? І, власне, з зазначенням переможців і, відповідно, деталей самих квізів, статистикою квізів і так далі. Ну що ж, я думаю, що можемо стартувати, напевно, з першим квізом. Давайте встановимо таймер. Ось. І так, я думаю, що ми можемо стартувати. Правда? Ну що, 5, 4, 3, 2, 1, поїхали. Так, перший квіз. Ну, а поки ви відповідаєте на квізи, хотілося б ще раз зазначити, що, будь ласка, колеги, слідкуйте за нашим Learn-порталом, дивіться на наші відкриті курси, програми, які ми виносимо на широкий загал, так? Для того, щоб шарити знання, досвід, обмінюватися цими речами і створювати щось нове та цікаве. Я попрошу наших колег в саппорті продублювати усі необхідні лінки в наш чат. І, власне, я думаю, що всі лінки будуть також зазначені і в нашому чаті в YouTube. Ми почали квіз перший, о 2 годині 18 хвилин, 2 хвилини, хвилинка до завершення першого квізу. І так, перший квіз, час вийшов. Ну що, переведемо подих і стартуємо другий. Так? 5, 4, 3, 2, 1, go! Не забуваємо, колеги, про те, що триває конкурс на найкращий коментар у Фейсбуці, а також паралельно з цим триває конкурс на найкраще відео, на найкращий відеофрагмент, який ви будете поширювати про нашу конференцію у Інстаграмі. Тому, будь ласка, активно приймайте участь також і в цих конкурсах, в цих розіграшах, і це буде достатньо цікаво для всіх. Отже, триває другий квіз, ще 2 хвилинки. Зосереджено працюю над квізом. Номер 2. Хвилина до завершення другого квіза. Стоп. Є. Другий квіз завершено. Сподіваюсь, всі встигли попрацювати із ним. І третій квіз. Ще раз. 5, 4, 3, 2, 1. Старт. Так. Хвилина пройшла. Нагадую, ще 2 хвилинки на завершення третього квіза. Загалом було би цікаво запитати у вас, колеги, а як ви поповнюєте і підтримуєте свої знання та досвід в актуальному стані? Так? Можливо, у вас є якісь свої цікаві лайфхаки, які ви можете запропонувати для нас, ну, як для учасників конференції, як то кажуть, від учасника до учасника конференції. Так? І от по завершенню цього квіза, третього квіза, було б дуже добре і цікаво поділитися цими моментами в чаті. Тому, будь ласка, заохочуємо вас до цього і будемо раді подивитися, подискутувати, зокрема, власне, і на цю тему. Хвилинка лишається до завершення третього квіза, фінального квіза. І будемо переходити до нашої останньої доповіді на сьогодні, але після неї, як ви знаєте, буде головна подія цього потоку, цього стріма. Це, власне, сам круглий стіл і обговорення. От, тому, будь ласка, доєднуйтесь, і у вас буде цікава можливість задати, знову ж таки, питання, але вже експертній групі. От, що я вважаю, що також може бути, як то кажуть, хорошою допомогою вам у вашій роботі, у вирішенні ваших особистих задач, робочих задач, ну і безпосередньо в розумінні того, як і куди рухатися, власне, в напрямку дата-інженірінгу. Так, стоп. 27 по. Третій квіз завершено. Дякуємо вам, колеги, за участь у квізах. Відповідно, як я вже повторювався, згідно умов цього конкурсу, статистика і переможці будуть надіслані листом фоллоуапом на всіх учасників конференції. Тому, як то кажуть, тримаємо кулаки за переможців. І я думаю, що даний приз у вигляді підписки, трьохмісячної підписки на продукцію видавництва Ореллі, так, на сайті, офіційному сайті цієї компанії, стане вам у нагоді. Дякуємо вам. А я з приємністю хочу перейти до наступної нашої доповіді, наступного доповідача. Дозвольте мені представити цього чудового фахівця. Це наш Олексій GATSKEVYCH, Senior Delivery Manager, і з надзвичайно цікавою темою Operational DataHub on Liberty Mutual. Нагадую, це надзвичайно великий, потужний аккаунт із практично всім спектром технологій, які можна застосовувати в IT-сфері. Тому, будь ласка, вітаємо Олексія, і ми можемо розпочинати його доповідь. Дякую.
Обіцяють одне й те саме, але EPAM пропонує більше. Отже, які вони плюшки від співпраці з EPAM? Ти можеш приєднатись до нас з будь-якого куточка України. Треба почекати сантехніка або нагодувати сусідського кота? Без проблем. Ми піклуємось про твоє здоров'я. У нас круті бонуси за рекомендацією друзів. Ми навчаємо та розвиваємо експертів, ділимось досвідом і кращими практиками. А ще ми разом подорожуємо та волонтеримо, програмуємо з дітьми, граючи. Для нас діє безліч знижок та є можливість релокації. І куди ж без цікавих проєктів? У нас їх сотні на будь-який смак. Обирай стек, клієнта та гайда з нами. EPAM. Фокус на твоєму рості.
Hi everyone, welcome to Autumn Data Conference and welcome to this presentation of delivering telecom and broadband data solutions. My name is ALEKSEY GATSKEVYCH. I'm delivery manager in EPAM Netherlands and I'm also a lead of our Netherlands data practice. And today we'll talk about one of our bigger customers for whom we have delivered several interesting data solutions. We'll talk about our main product, our main platform. It's called Operational DataHub, a little bit about how it was envisioned, what kind of problems it solved, and the architecture and technology used in development of it. We'll talk about some of our other solutions, anomaly detection, integrations in various data products and internet performance dashboards. And I'll tell you a little bit about delivery model, about how we actually managed to do what we have done. Right, so we'll start with the customer profile. Who is our customer? Our customer is one of the world's leaders in broadband, video, and mobile communication services. It delivers next generation products through advanced fiber and 5G networks, connect million subscribers across Europe and United Kingdom. This sounds a little too marketing-like. So here is what it actually means. Basically, our customer provides two types of services to users: entertainment and connectivity. Access to some kind of TV content, TV series, movies, sport events, and so on and so forth is an entertainment part. It has millions of users. It has multiple clients, like set-top boxes, basically a box in your apartment that receives the media content and projects it on your TV. It has TV applications, mobile applications, web applications, multiple clients. As you can imagine, there is a lot of country-specific functionality. Our customer is an international company. It operates across multiple countries, and there is a lot of difference available in the Netherlands or in, let's say, United Kingdom. And the difference is not only in functionality, the difference is also in content that is available. Some, as you know, some TV shows may be geographically locked and restricted. As you can imagine, the underlying platform, the underlying digital TV platform and entertainment platform has immense complexity. It's hundreds of components. It's very complex interconnected systems. Right, and the second part of organization is connectivity. Historically, these two parts are not very much connected. So connectivity part, the part provides you with Wi-Fi and European customer with Wi-Fi and broadband connectivity, also has millions of users, also has in customers' homes, like modems and Wi-Fi boosters and whatnot, has some mobile application to configure a home network. So the thing is that these two silos historically are quite different parts of organization, and they do not exchange a lot of data, and they do not operate together. And the thing is that these two parts of organization actually affect one another quite a lot. For example, when there is a Formula One competition and it's being watched by millions of users, it can affect broadband connectivity because it uses up bandwidth. And similarly, any problems with internet probably will affect customer experience with the digital TV. Probably the quality will drop, or even translation will stop. So yeah. These are two silos. They are not connected at all, and they're not connected on organizational level, but still there would be a lot of benefit to make data available from one another. Right, so we have, for this customer, we have developed multiple data solutions. Here is an overview of general landscape of these data solutions. The main thing that we have developed is operational data hub. It's a monitoring, it initially was envisioned as monitoring system, but then it evolved into advanced data analytics platform. And underneath it is streaming data processing. Then together with the operational data hub, or ODH as we call it, we have developed test execution and data hub. It's a performance testing solution synergic with ODH. It utilizes data storage and analytics capabilities and allows us to know in advance how the system will perform with all the millions of users. And then utilizing this platform and leveraging these platforms, we have also delivered a couple of things that contribute to AI ops. Anomaly detection, alerting, neural network based systems, that help operations team. And the last piece that I would like to bring up to your attention is Internet Performance Dashboards. It's basically for connectivity part of organization. We have delivered telemetry data to evaluate and assess our quality of service. So let's start with Operational Data Hub. Here is how we and the customer came up with the idea. The initial problem in such a big organization is that problem solving is mostly reactive. And when I say problem solving, it's mostly, technical problem with digital TV platform in production. Historically and traditionally, digital TV platforms are launched with minimal monitoring. And then as the problems arise, the monitoring solutions are being expanded, mostly reactively, and it results in multiple monitoring solutions being developed for different parts of this large system. And then obviously these different parts of the systems are siloed. As I mentioned before, connectivity and entertainment are not connected. And because of the diversity and complexity of the resulting monitoring solution, it's really hard to integrate with. New components are a nightmare to join. It's a nightmare to make new components join monitoring, and it's costly to maintain. And then again, because the monitoring data is stored in different systems, it's really impossible to correlate between them and really expensive to troubleshoot. And in addition to all of that, as you probably can imagine, it's hard to scale. So we came up with this idea, right, with requirements for Operational Data Hub. Let's get all the data together from set-top boxes, modems, and backend platforms in video on demand and digital TV industry. It's traditionally called head-end. These platforms should be very easy to integrate with. It should provide near real-time performance. It should be scalable horizontally, ideally linear, but as close an approximation as possible. And it should, in some future, support data analytics. So basically what it will be one monitoring platform, centralized platform that will replace multiple solutions with a holistic system and provide end-to-end insight into health of the overall platforms. So that is actually what we have implemented, right? We have implemented a kind of streaming data processing platform called ODH, which ingests all the various technical data from data centers, as low as network layer, from head-end, basically a backend platform, modems, set-top boxes, and performance validation platform, and processes this data and presents it in some kind of human readable form. The results of us implementing this platform, just to give you a glimpse of it in advance, the results of us implementing it were quite fruitful. The adoption in the company was, in the customer's company, was quite wide, and ODH allowed the company to support agile methodology, because basically because of ease of integration, it allows very quick, it allows basically any cadence in release cycle. And because of it's so flexible, it supports multiple release trains in multiple countries and environments, and it basically supports as frequent releases and as frequent production code drops as we'd like to have. And then on top of ODH, we have delivered some data products. I'll talk a little bit about them in detail later, such products as anomaly detection, correlations, predictive modeling. Basically, we have a lot of tools at our disposal with all this data to do some predictive capacity management, to get insights into user experience and undertake root cause analysis should the problem arise. Right, so this is just to give you an idea of the scale of the system. Currently, it's deployed on premises, on bare metal, and it's approximately 500 servers and more than 1 million Kafka messages per second, hundreds of Spark jobs, thousands of pull requests in the repository. So this is the scale. And I'll stop briefly on which technologies we have used in developing of this operational data hub. So this is approximately on a really high level the architecture of the solution, right? So you can see it's in general more or less standard data pipeline and a standard streaming data processing solution. By now, it's I would say these components are de facto industry standards, but back then when we were inventing it, it was a little more up in the air, right? So you can see we collect a lot of information from applications, event collectors, third-party APIs, logs, files, and object storages. And then it gets ingested into Kafka, and event streaming uses Mirror Maker. And then it gets transformed by Kafka Stream, by Spark, and some Dockerized applications. We are also utilizing our homegrown replacement for elk stacks, Logstash. It's called Logthresh, written in Rust language. And then for data storage, we have initially used mostly Elasticsearch, but then we have introduced Prometheus for time series database as a time series database, and ClickHouse. Then on analytical side, we have some notebooks, and we have Pandas, Desk, Spark, TensorFlow, whatever data analysts and data scientists need. And there is a human readable output in Grafana dashboards and in Kibana dashboards. So this is on a high level, the architecture of the platform. Of course, you know, when you look at the transformation column or output column, it actually represents many hundreds of various transformation Spark jobs and various dashboards that are used by different teams and parts of organization. Right, so if we talk about data flow, you can see that it's also kind of similar to the high-level architecture. We have ingestion from head-end applications. Applications use FileBeat usually to create Kafka messages from its logs. And we use Flume to ingest metrics from set-top boxes. These messages get into Kafka. They are processed by Kafka Streaming or Spark, and then they get stored in Elasticsearch or time series database and represented in Kibana and Grafana. There is actually very different retention policies we have for different parts of data. It's not visible on this diagram, but basically we have the capability to process data almost immediately, and we have the capability to retain data for, let's say, weeks or even a month to perform some advanced analytics using it. Right, so these are the guiding principles and main technological pieces that we have used to develop this huge data processing platform. Right, we used infrastructure as a code as a principle. So we relied a lot on Ansible, we relied a lot on containerization. Another principle that we had, the system should have no single point of failure. It's one of the mission critical systems for our customer. It's basically a monitoring solution everyone relies on to make sure that production is up and running, that everything works. So there shouldn't be any single point of failure. Any server that got damaged, that has hardware failure, shouldn't result in system not responding. We invested a lot into immutable infrastructure. The procedure of dealing with a faulty server is to throw it out of the window and set up a new one. Data is replicated throughout the server, and in small setups, we had all the servers run everything, with small exceptions, but generally all the servers were interreplaceable. We have utilized, which is a common problem with the data platform, we have utilized local ingestion points to traverse security domains boundaries. Technologically, as I mentioned before, we relied heavily on Elastic Stack with Kafka. We have eventually replaced Logstash with our homegrown replacement, and initially we started to process data with just Spark, and then Logthresh, and then Kafka streams. And currently, we are undergoing a cloud transformation. So basically, we would like to make this solution utilize a little more of cloud capabilities, especially in terms of scaling and availability of data processing. So currently, we are working on making it a hybrid cloud solution. Right. So the second solution that I would like to introduce to you is anomaly detection. Initially, anomaly detection was developed as a piece of software that would help operations team. Our customer operates network peering servers which exchange traffic with large networks of other internet providers, and they at the time of the development of anomaly detection, they had like living humans observing the traffic patterns and seeing if there is something shady going on. So we basically wanted to create a piece of software that will be able to do that, to detect anomalies, to detect irregularities. And there are many different types of irregularities, right? Traffic can be absent when it should be present. There is expected spike, and in reality there is no spike. Things like that are all anomalies. So the key requirements for anomaly detection for us was that we need to detect irregularities in time series. The detection should be automated, and it should be as frequent as every 5 minutes. It should be adaptable. It should be adaptive and customizable. It should be possible to tune the detection for accuracy and performance. Should be obviously horizontally scalable, run on premises, and integrate to existing infrastructure. And one additional requirement that we had from our customer, because of their previous experience, we had to implement it in Python. Right, so this is the solution that we have came up with. And this is the evolution of this solution. These are basically the steps of how we have developed this anomaly detection. Initially, our implementation was an analytical formula to detect different types of anomalies. We basically created a formula for, drop in traffic, sudden increase in traffic, today being not like yesterday, things like that, were all encoded in some analytical way. But then we went on and replaced the analytical formula with neural network and trained this neural network model on historical data and improved its performance based on feedback. And interestingly enough, it turned out that neural network actually takes a lot less resources and provides a lot better accuracy than analytical solution. Then we have developed some kind of visualization UI to make it easier to basically human observer to interact with the system. And we created an ability to provide feedback on UI and basically train the system, train the model further based on human input. Improved detection based on human feedback. Right, and then to this anomaly detection solution, what we have added is an alerting engine, right? As you can imagine, any complex system has an alerting engine that somehow is used to notify first line support and then second line support and then third line support about incidents that are happening and things that need to be addressed. And we have basically managed to create an engine that would be integrated with anomaly detection, and that will provide alerting that doesn't require human input. So this is a brief history of anomaly detection, and interesting thing about it is that it's very synergic with our operational DataHub platform. Anomaly detection allows us to detect anomalies. While initially it was developed for network traffic, it can detect anomalies in any time series data. And the operational DataHub platform had a lot of time series data. So we applied one to another and received a lot of valuable data about how the system performs and a lot of alerts when something goes wrong. Right, so other things that we have used operational DataHub and this data solution for is performance testing. We actually created another system called test execution in DataHub that is basically a UI to orchestrate multiple JMeters that will generate a lot of traffic towards different systems of video platform. And while this traffic is being generated, while this load is being generated, ODH performs normally. Operational DataHub performs normally, accumulates data, and provides kind of analytical capabilities, provides visualization of what is actually going on with the system. So it's kind of nice synergy between two systems, right? We have an advanced correlation and monitoring solution, and we have a performance testing solution. And first is kind of enhancing, multiplying the strength of the second. And another thing that we had used operational DataHub for, we used it to actually proactively manage capacity, figure out where we are running short of hardware, and predict how much hardware we'll need to support growing number of users. Again, it's a synergy with performance testing solution because performance testing provided a lot of input into this process. And the next step, obviously, because we now have quite automated performance testing solution, we have a lot of capabilities for root cause analysis. We have a lot of capabilities based on anomaly detection. The next step would be AIOps, basically achieving a fully integrated ML-driven anomaly detection topology and correlation framework that has the capability to correlate events from distinct domains and display them in one single end-to-end holistic view, showing customer impact and possible root causes. Right. So basically, we would make a system to detect anything that goes wrong with the system. It will obviously provide a lot of operational benefits. It will improve customer experience, because we will be able to address problems faster. It will probably save quite a lot of money by reducing the number of calls to customer care, and will probably result in higher net promoter score. So that's what currently is being worked on, and basically this AI ops, we consider it to consist of 4 building blocks, right? Generic anomaly detection framework, which we already have in place, generic correlation framework, which we kind of have in place, generic topology framework. In 2021, we made really good progress into that. and generic graph-based root cause detection, which is also well underway. In general, there is a roadmap for AIOps that we have for 2021 and 2022, and we are working on it right now. It's quite an interesting solution, quite an ambitious goal. So that's it about AIOps and our goal towards it. And the last piece that I would like to show is something that we call Internet Performance Dashboards. This part of our data solutions is something that we have delivered specifically to broadband, to internet connectivity part of organization. And the question that we tried to answer for them is, what is the state of our internet delivery network? How is it different between countries, between different products? How it affects our customer and how it affects quality of experience? And then obviously, when we are answering that, if we see a drop in quality of experience, how do we address that? What are the roots of the problems, and how we can provide proactive customer support? Basically, how we can support our customers before they actually need support, right? And it's kind of a similar solution to ODH, just a very specific application of it. So we used ODH to ingest and operationalize cable modem data. Basically, cable modem send signal that end up in Kafka, get processed, get stored in various data storage solutions. We ingest and operationalized access network data, and then we ingest and operationalized quality of experience data. We correlate it. We provide proactive customer support. And we are currently well into the latest stage. We have a lot of customers that are actually benefiting from this solution. Right, so this is on a very high level how it looks like, right? A lot of dashboards that provide information about how well is internet performing for various customers. The technology behind this solution is, you can see on this slide, it's also by now more or less de facto standard in the industry. Raw data is ingested from HDFS and Cassandra. There is a simulation layer that's used for data discovery, metric design, and dashboard simulation. There is processing layer that where Spark jobs produce metrics from raw data. There is a long-term storage in Graphite because we actually need, for this particular solution, we actually need data for a longer time than just, process and forget it. And reporting layer, we used Grafana for visualization. It was, this solution was deployed in Austrian data center. And we faced some delivery challenges, right, in developing this solution. It's not always easy to interact with the customer about data projects, because the visions in the beginning of data project is usually ambiguous, and it's difficult to choose and design metrics that will actually allow to reflect on business problems. Right. Another problem that we faced was ingestion and consolidation of multiple sources within the network hierarchy. Basically, we need a lot of different data sources with different reporting frequencies, with different granularities, and we still need to make them work together. And then efficiency was another issue that we faced. Basically data sources that we dealt with could generate terabytes of data per day per country, and processing it and storing it is not a cheap matter. And obviously dev environments were another challenge, because there is only so much you can fit on desktop, CPU and RAM constraints. Right. So you can see we used some rapid prototyping. We had some simulation layer. We use bokeh, and it's an interactive visualization library for Python. And it actually proved very helpful to have an ability to really quickly communicate with product owners and refine requirements, showing them some concrete example of what can be extracted from data, of how it can be presented. And after we have implemented the system, we have very positive results. Actually, we have very positive results. We have performed a delivery satisfaction survey with the customer, and the customer was very happy with what was delivered. I think it's the best confirmation that what we have done was actually useful. Now, next steps, what we are looking to do next in this domain of internet performance dashboards, we are looking to deliver these dashboards to different countries and customize them a little bit to different countries. We would like to be able to help better with customer calls, especially to be able to work on predictive cases. And we are going to refactor some of the smart Wi-Fi. It's one of the technologies that our customer is implementing, dashboards, and operationalize new telemetry data sets. So basically, we have implemented a good solution. We are going to support its adoption, wider adoption, and we are going to add new functionality, add support for the new functionality to it. And we'll learn a couple of lessons along the way. The success factors, we believe, were transparency and strong collaboration with the customer. It's impossible to develop data solution in separation from business question that is being asked. Therefore, we had to have frequent demos and brainstorming session with key stakeholders, and it really helped that, you know, at least part of this solution was developed before this current COVID situation, and we were able to actually sit in the office and discuss and brainstorm and see what needs to be done. And then usage of open source tools helped a lot for rapid prototyping. We wouldn't say I wouldn't say that everything was perfect, and there are things to be improved. For example, we really need to adopt a better backlog managing techniques and requirements handling, and we need to have a better validation pipeline in order to identify gaps in early stages and not proceed with, you know, full-blown implementation and then figure out that something that we have done actually cannot be used. Right, so that concludes my story about different solutions that we have implemented, and I'll talk briefly about what made it possible for us and how we actually delivered it. Right, so our team is global. We have almost no preferred location. We have people working from everywhere. I'm physically in the Netherlands, and a lot of my colleagues are in the Netherlands, but there are people from everywhere: Hungary, Belarus, Ukraine, Russia. I don't know. We had a guy in Bulgaria and a couple of people from Spain. So it's really a global team, and as a result, from such a diversity in location, it's also very multicultural. And I think one of the key success factors was that we worked really closely together with the customer. It was a combined team of us with the customer, and we went as far as to have actual exercise in pair programming. It really helped to, you know, get on the same page, to be on the same frequency and work together. And then we had a lot of benefit from being together with the customer in the same office. So we paid a lot, in any sense of the word, to a lot of attention to business trips and on-site presence. Despite how well it's working currently with lockdowns and quarantines, it's still a lot of benefit to have a face-to-face meeting in the office, to write something on the whiteboard and be able to discuss things really rapidly face-to-face. And another key factor of success, I think, was that we never shied away from being on any level of engagement. We provided full range of services, from very trivial stuff augmentation, where our engineers just join customers team and help customers team, to really a solution that we have envisioned and that we have implemented and that we have delivered to production and operated in production. And everything in between those two, right? So we can be visionaries if the customer would need a vision, or we can be, really working hands if the customer would like a pair of working hands. So this shows the geographic distribution of the teams that worked on the data solutions that we discussed. And yeah, as you can see, we are from a lot of different places in the world. Thank you. That concludes my presentation. Thank you for your time. And yeah, I hope you enjoy Autumn Data Conference and the other presentations. Thank you and bye-bye.
Yeah, hello. Good day.
Hello again.
ALEKSEY. Yeah, nice to meet you. Thank you for very significant inputs for our presentation, with such great team, really great team. And I want to ask you a couple of questions, because our colleagues in chat provided these questions to you. So first one, what delivery issues you have during implementation and how you resolve them?
Right. So I would say two most significant issues in delivering data solutions in really large organizations. So the first one is adoption of data solution, basically introduction it to the organization. And the second one is making it actually useful to business. So I'll go through them one by one. First, adoption. It's really challenging, usually, to introduce a solution that will replace a number of other solutions, because people are used to doing things a certain way, and people are used to certain interfaces. So the way we did it, the way we managed to overcome it with specifically operational data hub, we made integration with it extremely easy. It was designed in such a way that all the work was on our side, on the side of operational data hub. All the components that needed to send data to operational data hub, they just installed FileBit next to their log files and just send log files as is to Kafka. And we will do something with it, and we will strip it out of unnecessary parts and process it. So obviously, this implementation is a problem in itself. It creates a problem because because log files is not a fixed interface. They change over time and pipelines break. But this is a concession we had to make in order to make integration as easy as possible. And that actually promoted adoption. When it was widely adopted throughout the organization, we could introduce some restriction on the interface between components and our platform. But yeah, basically, this was the most challenging part, making people in different departments, not reporting to us, not controlled by us, to use the system. Yeah. And then when we actually have, received all the data, and we had all kinds of data possibilities in our platform, the second challenge was to actually make it useful for business. It's very easy to make a monitoring platform, right? Because the criteria is simple. It should show what kind of things are going on with your backend, what's happening, green, red, yellow. That's it.
Yeah.
It's a lot more challenging to make something useful for business because it's a chicken and egg problem. Business asks what you guys can do, and data platform answers, we can do whatever, just tell us what you want. And there is no way around it other than sitting together, trying to figure out something useful, implementing it, and seeing if it works, if it needs adjustment. So it's kind of an iterative process. And as I mentioned in the slides, it's a lot of help if you have some kind of tool in place for rapid prototyping, for rapid demonstration of what kind of usages can be, what kind of benefits can the business reap from the data.
Yeah, and one more question in the context of your answer. Yeah, so actually, how you motivate people for these changes from delivery manager side perspective? Yeah,
in the customer organization or in our organization?
In customer, especially in customer. Yeah.
So I would say, to be honest, we have used everything. We have used, we have flattered them, we have bribed them, we have coerced them.
Okay.
It's I wouldn't hold the truth from you guys, but fear is not a weak instrument in that. If you tell people everyone has adopted it, everyone is going to be in this data platform, and you are the only one who is not in, then people listen to you with more attention. But obviously, the main way that we used was selling the benefits of the platform. It's currently it's in production. It's being used for monitoring, and it's kind of go-to solution for monitoring. So it's it has very upfront benefit of providing monitoring solution, and then on top of it, it's advanced data analytics. But the benefits are really close. It's like send your logs, and everything will be visible, and your system will be monitored.
Yeah. So yeah, we can say that we should make our difficult things, just obvious and understandable for all of us. Yeah.
And then we had a lot of presentations. I actually reused a lot of slides that we use internally in customers' organization, explaining what it is, how it's useful. It takes time. Adoption is not a process that will happen overnight. There will be setbacks. It's challenging, but if you persist and if something that you've created is really useful, then it will be used eventually.
Actually, yes, because process is always process. It needs a time. Sometime we need some time. Okay, thank you for your answer. And we have one more question from Vladislav. How long has your project been lasting?
So I would say from initial idea to actual implementation, to at least first results in production, it lasted as long as 2 years. And we have actually implemented the platform itself in about 1 year. And then we started to productionalize it and transition it to using actual data. And not surprisingly, it turned out that kind of something that worked in a test environment doesn't really work on production with production amounts of data. So there was a lot of very rapid, I would say, performance testing and refactoring to to adjust to this new situation. Every data platform works perfectly until the data starts flowing in.
And how you manage this load with your teams?
We kind of had very careful planning around it. We knew when the data will start floating in, when the data will start flowing in, and everyone took vacation before that, because we knew, like, you know, from September until the end of year, there will be overtimes, there will be difficulties, and we kind of prepared for it.
Okay, great advice. So one more question from our colleagues in the delivery challenge. What was the most time-consuming part?
So let's see, time-consuming part. Well, if this question is from delivery management perspective, like where the most resources have gone, the most man hours have gone, most were spent on developing actual data pipelines. Surprisingly, the platform itself took less of resources, but that's because of the width of the platform. It's really broad. It's really taking in a lot of data, and it's like the amount of components from which it ingests data is like 100. It's a lot of components, a lot of very different, diverse data, a lot of different retention policies for data. Some data is stored minutes, some data is stored weeks or even months. I think currently there is even an infinite retention data. So basically, a lot of time and effort has been spent on actually developing data pipelines, creating Spark jobs, creating, you know, we have a homegrown replacement for Logstash, but basically processing data. I think we had a team of about 20 people working on just that for let's say the total development time of the project is now a little over 4 years. So we had team working for just that for 3 years. And they have no lack of tasks as of now. So it's still being developed.
Great scale, actually very useful, I think, experience, very deep, very precise, and very valuable experience. Okay, what about other questions that we have? Great, we have a comments. Such great performance, great presentation, so a lot of thanks. Thank you guys. And one more question: complexity of Spark jobs is connected more with the diversity of data than with complexity of data transformation, right?
So it depends. It depends. Basically, initially, the Spark jobs were really simple. Initially, we wanted to have an advanced monitoring in place, and that was it. Now that we are actually trying to get more complex results out of the platform, more complex data analytics, it becomes the complexity of data transformation, not just the diversity of data.
Okay, great. And traditional question from our side, as you know. What about 3 main advices to our participants? If they decided to work with big data, from your perspective, from perspective of delivery manager.
So from perspective of delivery manager, I would say co-location has its benefits, but do not shy away to work with people anywhere in the world. The nature of modern development is such that you'll benefit more from clever people regardless of their location than from people that are in specific geography.
Great.
It has its own benefit. It has its own difficulties, right? It's a little challenging, more challenging to organize people in 20 different cities than in one specific office. But the rewards are immense because you have access to the best people in all those cities. So that's one thing that I would recommend. Another thing that I would recommend is working with the customer. It's really important to kind of have demonstrate early and fail fast kind of approach. especially with large systems. The earlier you can show the results, the more likely it is that you will get funding for the next part. Because of this, because of how the big organizations work, it's rarely that we have the same benefit as, let's say, rocket science. We can build the rocket from the ground up and then, launch it only when it's ready. We have to build an engine and demonstrate that engine works, and then we have to build some other systems and demonstrate that these systems work. It helps a lot.
Yeah. And the last
advice that I would give is make your system easy to integrate with. That's the kind of self-explanatory, but it's also a little difficult from engineering point of view. It's not always pretty if it's easy to integrate with. So yeah, that's something that I would still recommend. If no one integrates with your system, regardless of how pretty it is, it will not be used.
Yep. Awesome advice. So thank you very much, Alexey. I see that we covered all questions. And one more time, thank you for your participation. Thank you for your time. And see you on panel discussion, I guess. Yeah.
It's been a pleasure. See you guys.
Yeah. See you. Thank you very much. So, дорогі колеги, ми з вами підходимо плавно до нашої панельної дискусії. У нас до неї залишається буквально кілька хвилиночок. Я думаю, що десь ми почнемо о 3:30, згідно графіку. Якщо говорити про наші сьогоднішні доповіді, нашу сьогоднішню роботу, сподіваємось, що наші доповідачі виявилися надзвичайно корисними для вас, оскільки я бачу, що було багато запитань, було багато коментарів. Я думаю, я впевнений, що наш з вами сьогоднішній такий марафон, тому що наша конференція – це своєрідний марафон, і ми вже на останньому кроці цього марафону, найбільш цікавому для всіх нас. Я впевнений, що і сподіваюся, що все-таки ви, напевно, згенеруєте ще якісь додаткові запитання для нас. Ви зможете зв'язатися з нашими координаторами. Звісно, ми будемо фоллоуапити усі матеріали, будуть надіслані матеріали, будуть надіслані лінки, будуть надіслані відповіді на квізи, переможці, статистика і так далі. І ми сподіваємось на ваш зворотний зв'язок, на ваш фідбек стосовно, скажімо, користі, тієї інформації, яка розглядалася у нас сьогодні на конференції. Ми будемо дуже вдячні за цей фідбек і обов'язково будемо враховувати дану інформацію для нашої наступної і, я впевнений, продуктивної такої співпраці і кооперації. Стосовно нашого з вами часу, у нас 5 хвилин лишається до початку круглого нашого столу або панельної дискусії. Я з радістю о 3:30 передам слово іншому колезі, Дмитру. Він буде модерувати цю дискусію. І після нашої панельної дискусії, звісно, ми проведемо офіційне закриття нашої конференції. Якщо говорити про саму панельну дискусію, то варто відзначити, що в нас буде декілька фахівців, не так? І я вас дуже прошу активніше задавати запитання, для того, щоб ця дискусія тривала яскраво, динамічно і цікаво для всіх нас. А зараз, я думаю, ми можемо мати цю невеличку перерву, паузу, буквально в 4 хвилини. І сподіваюся, що наші матеріали, які зараз дівчата включать, будуть корисні для вас. Знову трішечки про EPAM. Дякую.
обіцяють одне й те саме. Але EPAM пропонує більше. Отже, які вони плюшки від співпраці з EPAM? Ти можеш приєднатись до нас з будь-якого куточка України. Треба почекати сантехніка або нагодувати сусідського кота? Без проблем. Ми піклуємось про твоє здоров'я. У нас круті бонуси за рекомендацією друзів. Ми навчаємо та розвиваємо експертів, ділимось досвідом і кращими практиками. А ще ми разом подорожуємо та волонтеримо, програмуємо з дітьми, граючи. Для нас діє безліч знижок та є можливість релокації. І куди ж без цікавих проєктів? У нас їх сотні на будь-який смак. Обирай стек, клієнта та гайда з нами. EPAM. Фокус на твоєму рості.
Ну що, всього хвилина лишається до нашої панельної дискусії. Я попросив наших організаторів ще раз надіслати усі необхідні лінки і матеріали, які будуть корисні для вас, друзі, стосовно нашого EPAM-порталу, стосовно наших кар'єрних можливостей, стосовно можливостей навчання, тому що EPAM є одним з найбільших провайдерів такого роду сервісу, так, для вузів, для людей, які бажають вчитися і розвиватися в Україні. Ось. Ну і добігає наш час, хвилина часу, і ми стартуємо. Привіт, Дмитро.
Привіт.
Передаю тобі слово і розпочинаємо нашу панельну дискусію.
Дуже дякую, Дмитро. Я переключусь на англійську. У нас сьогодні є наші спікери, які будуть також підтримувати цю розмову. So, let's kick things off, guys. Welcome everyone for joining. It's Saturday. Thanks for making it happen. I hope we'll have a very productive discussion today. We'll be talking about very trending things in data space. We've got perfect speakers from all over the world, and I hope we'll have a live discussion. And I do encourage everyone to step in, to post their questions, and we'll be reviewing all of them and making sure that we can answer as much as we can. So before we kick things off, I'd like to introduce our panel speakers. So we've got Athena here, who is a Senior Director in Data Competence and Development Leader in EPAM. We've got Tom Zubitsky, who is a Director and a Technology Consultant. We've got Peter Travkin, who is the Senior Manager, Data Analytics and Consultant Space. And also we've got Umit Merk Kakman, who is our Senior Manager in AI NML space. So I'd like to quickly provide an overview of what we'll be talking today. So our main subject for discussion is modern trends in data and the main challenges that we are facing today. Well, back in 2019, in 2009, it all started with NoSQL as a rapidly emerging trend. Then in 2012, it was all about Hadoop. Back in 2015, it was all about migration to cloud and emerging of data science. Then we started talking about AI/ML in 2019. So the key question here is, what's next? What's the next big thing that will be trending? Who'd like to start, guys?
So I think I can. So hi, everybody. Thank you for joining. And so Hadoop was a big thing, and it changed significantly the way how we manage data. And over the years, the cloud pushed it even further, because this is a powerful concept of separation of compute and storage actually enable a lot of interesting analytical use cases. So you don't need to have one centralized database, so you can store data separately and engage expensive computation resources when you need it on demand. But it's still expensive, and you're still paying pretty significant money for this infrastructure. And the biggest question on the market right now, how we can make sure that whatever we're building actually very well aligned with business objectives, and how we can produce value, and whatever we're building has a good adoptions among users. This is why data product concept was introduced by many different parties, and the EPAM was a big supporter of this concept, and the data mesh kind of articulated this concept kind of a couple years ago. And nowadays it's actually a hot topic. So everybody are thinking how to build kind of friendly ecosystem which allow you to create data products and make sure that this data products has a good adoption, and there is a clear ownership on products, and there is a clear kind of return of investment. But building product building one data product is a challenge. But if you're building thousands of them, and there are like hundreds of product owners and the product consumers, and how you can build kind of friendly ecosystem, how can make sure that data product produce kind of the value that you're expecting, and how you can support this value on long run. So this is why data apps is getting very hot, and there are many customers who are trying to introduce this data apps methodologies, and trying to introduce it among the enterprise, just to make sure that we can kind of repeat this best practices and be able to produce a good quality of the products over many years, or kind of many organizational groups. When we add machine learning to this equation, the situation became even more complex, because machine learning algorithms learn from data, and if there is some biases, some kind of unpredictable data drifts that you've never seen before, it can significantly affect the result that this model produces. So the question is how you can build kind of reliable machine learning model which produces a reliable result, and you can easily explain, and business can trust and understand how it works. All of these questions are getting hot on the market, and with the computer vision, this situation is even more complex, because how you can build machine learning model and make sure that you have enough content to train your data, how you can ensure that whatever you build actually produce expected result. So I think my colleagues will give you a little bit deeper dive in this concept. I think we can transition to next topic is kind of data mesh. Thank you.
Basically, that's a good topic to discuss, because until now the enterprise has used a centralized strategy to process extensive data with various data sources, types, and use cases. However, centralization requires users to transport large volumes of data to a central data lake, right, to be queried for analytics. And this is really time-consuming and expensive. And nowadays, global data volumes are increasing very rapidly, and query methods in a centralized management model start failing to respond at scale. So how data mesh actually helps with its distributed architecture and decentralized concepts of data storage and access in solving those problems?
This is really a fascinating subject, and at EPAM we spend quite a lot of time trying to figure it out ourselves, because on one hand, organizations, they do want to have centralized data platforms, or something that acts as a coherent single data platform. But in the same time, given the scale, both in terms of data volumes, but also technology, majority of big organizations will have a multitude of different technologies deployed at any given time, and different audiences, from HR to finance to retail, when they will have focus on individual brands that will require bespoke data products to support them. This becomes a quite significant challenge. And data mesh, it tries to resolve that on, I guess, 3 main levels. So level number 1 which is technology, and here data mesh really came to light with the advancement of cloud computing, which allows you to quickly create the scale, but also a single coherent underlying infrastructure. So despite the fact that you might have multiple different, or hundreds or even thousands different products, you can still run on top of a single cloud platform which provides uniformity in terms of infrastructure you deploy. You can deploy standard security controls, governance controls, etc., etc. But also what that requires is then a set of standards that needs to be implemented across different data products. The key concept, one of the key concepts when it comes to data mesh, apart from focus on individual domains, is to provide interfaces that are going to be standard. So effectively, if you think about microservices architecture, which is not miles away from where data mesh is aiming, is to provide a coherent access to those data products. So they're clearly defined from raw data all the way to transform data, be it outcome of ML models or analytical information going through a standard semantic layer. Those interfaces need to be defined, and they need to be fairly standard across multiple different data products, so those can effectively be meshed together. But what that also requires, taking the next step, the last sort of key category here, is change within organization, which is not very often talked about and well understood. But in order to be able to utilize those products, in order to be able to support it, and let's not forget that data mesh requires people coming together from different domains, all the way from system engineers through data engineers, through data science, MLOps specialists, all the way to business knowledge, because otherwise those data products don't have any real use. The business context, the knowledge that turns data into useful information needs to be there. That requires a really strong cross-functional team culture within organizations, and that's, as everyone knows here, is very often a challenge. Data mesh tries to address that on 3 levels, and that's what we're doing with Data Factory as well here at EPAM. And I think that this is still a journey. This concept is still developing, but definitely when implemented well, provides answers to quite significant challenges that we face at the moment when it comes to big distributed data ecosystems.
And I think that's excellent overview of how data mesh works and how it can help. I think we can also like take a little bit step back and see why this concept emerged, right? Why we're talking about it now, why we didn't talk about like several years, maybe 5, 10 years ago. Like the thing is that data aspirations of companies have evolved beyond business intelligence. So we have now, each organization is using machine learning to design the product. The expectation is how to democratize data. So most of the workforce can use it. And actually modern data management is being disrupted because of datafication, which means that every single aspect of life now is being converted into data, which should be digestible for analysis. And as Oleg also mentioned, technology trends that are fragmenting the data landscape. The most impactful trend, of course, is advanced analytics. It exploits data heavily in different ways, and for companies to stay innovative and competitive as well. So one of the reasons people started thinking that current architecture cannot scale, so current platform, they cannot sufficiently supply data to this kind of analytics. First of all, now we have a requirement that analytics should work both transactional and analytics data, and data should come at different velocity. And velocity of the operational systems is different from the velocity of the analytical ones. So, and also the speed of software delivery is changing. So with the new methodologies, we have increased data complexity as well. So if we add a strong regulatory requirements and data ethics, it makes like picture even darker, I would say. So for now, we need to integrate the core business functionalities and services with the third parties, because companies started to monetize data. They started to expose data with APIs, making them publicly available, and using open data at large as well. So for now, we have a data which is distributed between environments, which is decentralized, and with that in hand, like the monolithic design which we are used to or were used to like several years ago doesn't scale as we wish it should. And in this highly distributed environment, these architectures basically they will not anymore fulfill the future needs of the companies. And for now we think that like companies, they are at a so-called inflection point, like the time in life of the company when the fundamentals are going to change, when the approach to data management is going to change, and that's a good time. So that's a time when we make a crucial decision: either we change something or we go what we have and see what happens. So data mesh can help to make data platforms scale. It can reflect like the need and to remove the so-called divergence of the analytical and operational data planes which we see now. So with the two-plane data topology which we see when we have completely separate technologists working on the operational side and analytics side, so that's need to change. Why not to bring the data to end users just from the source? So not to copy from one technology to another technology. And what we also see, and what Tom mentioned, that data mesh can start addressing these challenges immediately. Bring data management areas closer, like provide a consistent view on how to uniform security, how to apply governance, make it more operational, make it more automated, and also if we see like how domain-driven design works, we can abstract the complexity for teams developing data products. And it's also interesting conversation about the product-centric development when team have like reusable building blocks and can deliver data products independently using the same principles, the same I wouldn't say technologies, but approaches at hand. So it should be a change both for architecture, it's an organizational change, and also operational, because it shifts data governance from top down to more federated model. And also to add what Tom has already suggested as a concept, so we need to connect the two planes, operational and analytical. We need to make it decentralized, federated, and here we also have a question how to decompose, right? We can decompose it in different levels, and classical approach suggests we decompose on domains. We also can decompose on a higher or more granular level as soon as we define clear boundaries, and we carefully arrange data for end users.
Yeah, you're absolutely right there. And one point that you've made that I think I personally now work with one of very big retailers, and the number of systems that have to interact within the data platform that both feeds the data platform but also take output is 52 different systems. Some of them are in the cloud, some of them are still very on-prem solutions. and the data velocity required is actually very fast. So one of the problems that at the moment we're resolving, and in fact, that's why we started to implement data mesh approach for this particular customer, is how to take data from multiple different points, from online when they go and browse prices online, but they happen to be in the store, from CRM system, multiple different systems, bring that as a product, and there's quite a lot of machine learning involved as a actionable information for a operative on a store floor, talking to the customer, having all the information available about purchasing habits, about what they are browsing for, just to suggest the right product and provide a seamless experience between online and mortar. When you think about it, and when you think about paradigms of what we all did 10, 15 years ago, which was data warehousing effectively, that would not be possible. Data warehouses had the cadence that was fairly inflexible. Now, with modern technologies, with data mesh, data ops, machine learning, and ML ops, that kind of scenario, when you can bring huge volumes of data, distill it, do something useful, and deliver that to the right person at the right time, becomes possible. Still extremely complex, but possible.
Yeah, really thanks for your insights, guys. Oleg, you mentioned at the very beginning computer vision. Let's talk a little bit about this. So it's expected that this market will reach almost like 50 billion by 2022. So I really think it's a trending thing, and we probably need to focus on it. So if AI enables computers to think, right, computer vision enables them to see, to observe, and to understand. It's used in industries ranging from energy and utilities to manufacturing and automotive. Who'd like to pick this up, guys? Let's talk about computer vision a bit.
Yeah, I can I can chime in a little in this part. So I think I really agree with what the data space is evolving into, like the data mesh concept, and it's also extremely interesting for an ML practitioner like me, because those kind of like cognitive AI applications can be computer vision, also NLP, requires really large amounts of data, right? You need to label them correctly, and and people like companies were using like supervised techniques, right, where you have like huge amounts of data, you label them, you specify the task, and they were like extremely accurate, right, often in areas where they can perform better than human operators. So that attract a lot of attention, obviously, but there is a lot of overhead when it comes to sourcing data, preparing data, labeling data. That really requires a lot of involvement from technical teams, also from the domain experts, right? So I think what the industry is going towards is more like resource efficient models and architectures that we sometimes aim to use less data, but learn the very same thing that we are trying to learn. But the second, if it is not possible, and in most cases where we really wanted to have like diverse set of data, we wanted to make sure that we represent the population in a fair or maybe bias-free way, we need to have this data in place. So the synthetic data generation techniques were evolving. This is also true for tabular data sets, but also same for like unstructured data sets, right? We can use some certain technologies, for example, today to generate humans, faces, their different properties. And then we can feed those into our models. And this is true, especially if you are trying to ensure the ethics in technology, right? If you're rolling out a product, and if some of the groups in the society feels ignored or discriminated, then that causes a lot of problems in a lot of dimensions. First, there's obviously a legal dimension, but there's also the market dimension, that you lose your competitive edge in that market. Probably those people are, going through different ways of, sourcing their products or using those products. So that's one thing, like privacy preserving AI is becoming really important. Hence, the data generation techniques are becoming a lot more important. And also in connection with, how do we use data? How do we generate data? How do we train the models? We see that AI at the edge becomes very important, right? The AI models that you use on your mobile devices or edge devices, used in an industrial setting or in a manufacturing site, etc. So that's also very much connected with the privacy. For example, if you think about the healthcare applications, right? You may train models in an isolated way in one hospital, which may not generalize well to all the other subpopulations in other hospitals or in other different regions. I also see, there are like really exciting developments in federated learning, where you don't bring data to the same place and then train models, but you are really training those models in their respective local environments. You don't share the data with the central place, but what you share is, what you learn during those local training periods. Then you aggregate those models. So I think these are the things that are really interesting. But in order this all to happen, everything that you guys mentioned, like a platform ops, data ops, how do we source data? How do we, bring that data together? Or how do we democratize that data to the different people within the organization becomes very important. I see a great tendency towards self-service. Like as a data scientist, we don't want to ask like IT ops or SysOps teams to provision us an environment, but we wanted to select the environment maybe from like a service catalog or something. And then we wanted to, don't want it to deal with the governance and all the security issues. And I think everything is converging towards like set of practices where we see that it works in the best interest of the organizations, but also I see that if everybody employs best practices, then like what differentiates you, right? You are basically hitting the productivity frontier. If everybody is using the state-of-the-art models, if everybody is using the state-of-the-art architectures, that's why I think in EPAM I find very interesting that we bring really a lot of different disciplines and groups together to think strategically about how do we execute our projects, like what makes us different, how do we create that competitive edge in the market. And maybe one last thing that I would add is when you bring like different practices in ML, like computer vision, NLP, or maybe traditional ML that you've been employing in different industries, there comes the question of multimodal AI, right? Those are, set of different techniques that are brought together to develop some certain product in a way that we as humans, understand and operate in our environment. And there were really like interesting applications. Like if I ask, hey, I'm looking for chairs and I like blue color, right? And then, for example, the agent or assistant might bring you all the blue chairs with different fittings, the things it, matches your criteria. So those kind of like audiovisual systems that are in place. Also, this obviously opens up a lot of opportunities in the future. For example, if I'm a person trying to find suitable clothes for the activities that I'm going to do for that day, then I can ask, okay, I have like business meeting, I have, social meetups, like what should I wear? And then depending on that the context, then assistant can bring all those, different contexts in one place. And it's possible with, having a common data space or maybe the embedding space of that information, that all different techniques that learn from that space in their own way. So I think these are some of the things that I really find interesting and I see that are trending.
Yeah, I think ML ops from engineering perspective, it's an interesting concept because what we see a lot that the organizations is structured in the way that the business is disconnected from data science group, and data science group is disconnected from engineering group, and eventually there is somebody else who is actually supporting these models in production. It creates an environment that's not really helped to kind of push this idea to actual execution and finally in the kind of deploy it into enterprise ecosystem. This challenge, it's required kind of new way of thinking. It means that all these technologies are not just changing how we process data, it's overall change our behavior and our organizational structure, how we communicate with each other, how we join in one single group, which has one common goal, and blending business users, data scientists, data engineers together, and machine learning engineers and data ops people actually help to push these products into kind of production much faster and has a much better predictable results. In order to achieve it, it's not enough to have independent engineering disciplines. They have to figure out how to work together. This is why EPAM did a huge transformation for the last couple of years and realign all of our data-related disciplines among 10 kind of major disciplines, but we also support like other competencies, and like computer vision, for example, we have a separate group for computer vision, we have a separate group for NLP, we also have a focus on different cloud providers like Snowflake and so on. But what is the most important, having like a cohesive team who is working together and delivering this value to the customers and building this data products and actually building platforms as a products as well, because it's important to understand who is actual customer of your platform. You're not just building this infrastructure and a lot of ecosystem without clear understanding who and how is going to use it, because any platform is a combination of professional services and self-service. So more you push to self-service, more people you will be able to engage, and more actual initial interesting ideas you will be able to realize, kind of building this friendly ecosystem which encourage people to create new products and communicate and build this kind of data democratization per se. It's actually our goal. And for this perspective, I mentioned these 10 data disciplines. Let's walk through them. So first of all, we have a leadership group, which includes data solution architects, data delivery manager, and the data technology consultant. They have a similar kind of goal, but they are approaching this goal from slightly different angles. So data solution architect approach it from technology perspective. The delivery manager help to organize overall development process and make sure that we deliver the product, kind of final product in time and required quality. And data technology consulting, they help to align this all of these activities with business objectives, because it's very important to keep it in focus and make sure that we deliver good quality of product, which will satisfy our business users. In order to collect all these requirements and understand if data actually fits these requirements, you need people who understand and business analysis and data in the same time. This is why we have a business intelligence analyst who are working with customers and playing product owner role for a while. So we have data software engineering and engineers and data DevOps who build this data platform ecosystem. They bring data into cloud in data platform and build all this kind of self-service capabilities for end users. We have data analytics engineers and data quality engineers who are building data products and make sure this data products has a great value for our customers. When we add ML component on top of it, we need machine learning and data scientists and machine learning engineers. And we recently introduced this machine learning discipline, and we start active hiring for that and training, because machine learning became a kind of engineering became a very hot topic on the market. We see more and more requests from our customers who already built plenty of machine learning model on their Jupyter notebooks, but now they kind of thinking about how we can push it into enterprise.
Yeah, thanks for this overview. I'm just curious. So we've got so many disciplines within EPAM, and we've got to unite people around some architecture, right? We are delivering solutions to our clients, and we'd like to make it consistent and unified in the sense that our architecture is basically following some standards. It's based on the experience that we've been building for our clients. And I'm just curious, so in terms of the blueprints, we have a lot. So can you elaborate a bit in terms of the blueprints, how important they are at the initial stage of any product to make sure that we are building something that we understand, and we are consistently telling our clients the story that this is the way it should be done. We're consulting them and we're leading them within this journey.
Yeah, as a competency center, we started from understanding technology, but very quickly we realized that technologies are important, but the way how you connect all of these components together, how you properly organize them and make sure that you're not missing any important, significant kind of components is also important. So that's why we invested a lot of building some blueprints, which play as a kind of playbooks and guidelines for when we start a project, which help you to articulate which components, which areas are important from data platform, how you store data, how you organize data in raw area, how you collect metadata, and how you organize different pipelines together, and how you expose the data. Because analytical platform is a part of ecosystem, and with a data mesh concept, you are actually pushing these boundaries to source systems as well. And there are a lot of business logic is pushed to actual source systems, so because it's much easier to kind of validate quality when you enter this data and make a cohesive environment where data operational and analytical kind of plates they work together and produce a great value. And so we actually created these blueprints and mapping them to different cloud providers. You can have many variations, but usually it's very depends on specific customer requirements. So for this perspective, we have our generalized blueprints, which are completely technology agnostic, but provide the main components that are important. And at the same time, we have more like specific blueprints, which are mapped to specific cloud providers or like systems like Databricks, for example, or Snowflake, which are becoming very popular nowadays. When we push these boundaries from a relatively small department to a bigger organization, we are facing many more interesting questions, because eventually when we try to avoid data silo. So when we moved from traditional data warehouse approach, we try to avoid building something that nobody can use anymore. And cloud provide a lot of technical capabilities for that. It's very easy to share data across different continents and between different regions. But having thousands of products and hundreds of users, it's not easy. And how you can build this ecosystem which allow end users to collaborate and produce these products and actually combine them together, because more products you combine together, more kind of dense semantic layer you are getting. So how you can build the environment which all of those data products will converge to one single semantic layer, which will represent the overall enterprise. And it's why we have a next level of kind of blueprints which cover this federation and how you can organize federated environment and make sure everybody, they quite independent. So there is a flexibility to produce these data products, use different technologies, whatever you're trying to build. But in the same time, they can communicate to each other. There is a common terminology between different departments. When we talk about price, we understand what exactly we're talking about. There is another interesting trend that I probably forgot to mention, is how you collect knowledge across enterprise. Because many companies, they figure out how to collect data, and cloud allow you to store like petabytes of data, so it's okay. But the challenge is how you interpreted this data, because a lot of this knowledge is not persistent in any forms. It exists only in kind of minds of subject matter experts. And it's not easy to get this information from here, because it's not the only technological problem. So you need to engage some processes, some collaboration, and be able to extract this accumulated organizational knowledge and persist it in specific form. And the challenge is how you're going to store it, because there is no clear structure, and it's really hard to come up with any structure which will fit all this knowledge, will fit. It's why enterprise knowledge graph became de facto a standard for metadata management, which help you to align our terminology, extract this knowledge, and persistent structure it in the way that later on the system can navigate and use this knowledge to add context to all of this data.
And also to add a bit on the blueprints, I think it's a great starting point to start a conversation with companies, right? Especially when we don't know the landscape, but we don't know the technology stack, the aspirations. I think we use it to start the discussions around what are the needs, how we could help companies, and also, yeah, we develop it further with the blueprints. And as Oleg also mentioned, some of them are technology agnostic. So even not having a technology stack in mind, we can have very interesting, very productive conversation on a higher, like abstract level on the architecture and subsequently add technology dimension to it as well.
Yeah, that's very good point, because what we talk about, I think one of the underlying things is complexity, something that you don't know how to resolve up front, and you have to find a way to organize it, somehow put order into it. And having those processes and blueprints help to do that. When you don't look at, okay, I've got Spark cluster running, and I've got Snowflake, and I've got something else, and I've got DB2 somewhere still in the state. You abstract it to a level like, okay, I need to accommodate machine learning, I need to accommodate still classic BI, I need to accommodate real-time data, and to somehow organize it. And that really helps to take a step back from day-to-day technology, think about what you're trying to achieve and how you want to put your ecosystem together. And then from there on, you can start making technology choices. In my day-to-day conversations with customers, having that set of blueprints and introduce that kind of higher level thinking makes a huge difference, and sort of helps customers to really look at their problems from different perspectives and come to sometimes very simple rational choices that previously weren't necessarily obvious to them because they were overwhelmed with these sort of different technical terminologies, different challenges, day-to-day fires. So yeah, from my perspective, this makes a really material impact on how you approach data problems.
Yeah, and guys, I'd like to step in because we have a question from our audience. The question is whether it's possible to use AI for code generation with reducing developers' footprint in data solutions. Who'd like to tackle that?
Yeah, let me briefly answer that question. It's an active area of research. Obviously, starting with a code completion, right? There were like tools, probably some of you are familiar. You start typing a line, and then it suggests the end of the line or a block of a code. You can train those kind of models, but aside from like code completion, code generation is also like a very hot topic because it enables companies to have like ML-powered pair programming, right? For example, GitHub has, I think, one such product. It was called like Copilot. You can go ahead and have a look at it, and I think it was based on the GPT-3, which is a very famous like language-based model. What you have to carefully think about is the data set and how you curate that data set, right? Because you need to have like maybe billions of lines of code, and when you're collecting the data, you have a great chance of introducing all sorts of seniority biases, right? Because probably the code that you collect will not be very pristine. Maybe there are like performance problems, right? The complexity. It is possible, but it requires, I think, a lot of work from my perspective. But I think in the future, as we have like more of these tools and more of these technologies, we will have like a much better and performant models in that one as well, and that will absolutely help tech teams to become faster or maybe more efficient. And it obviously has an educational role that that educate you, show you the best practices, and show you the good ways of developing software.
Yeah, I think we have
Any
reached.
thoughts on this? Or...
Yeah, sorry. So I don't think we have reached the point that the computer actually can replace a human. So eventually, it's a good augmentation tool, so which can accelerate your development, and probably kind of will help you to focus on more interesting tasks rather than routine things that you need to repeat over and over again. And next question is the knowledge, and more knowledge you accumulate over the time, and probably machine learning algorithms can help you to bring this to the point. It's like everybody using Google right now. So when we started, it was Google there. So we have to read books and figure out how to write this code by yourself. But eventually, Google help you to find the right answer relatively fast. There's even a term like Google development. So from this perspective, Google already augmenting this thing, and like how to use ML in your development. But moving forward, we see that I don't think we will have any lack of demand on data engineers. Demand is growing so fast that it's really hard to augment, because there are so many different legacy systems already introduced across the globe, and all of them require modernization, switching to new platforms, and we only at the beginning of the journey. Having a little bit help of AI, which will help us accelerate to transition this existing development logic to new modern technological stack, I think it will significantly improve it, but I don't think it will in any way affect the demand that we have right now.
I would agree. I think this is definitely happening, and it's getting better and better. I think the first level of augmentation was people copying and pasting from Stack Overflow. There's many jokes about that. Copilot is a great example, because Copilot is way smarter than other systems in the past. But I think this is only the beginning of the journey, and we will see more and more of that. But I don't think that will replace in foreseeable future data engineers or software engineers as such. It's going to be augmentation, which, let's face it, is very much needed. All of us at some point spent countless hours and days doing tedious tasks, repeating similar lines of code to achieve repeatable tasks. And if we can have augmentation to simplify that, and that gives us more time to tackle really interesting and complex problems, all the better.
And at the same time, the machine learning was successful to help end users, right? With the data catalogs helping to navigate the data, helping to build queries, make data findable, also helping end users with the data preparation. There are tools which successfully enable them to do that in seconds, and also data quality. Machine learning has been successful in solving these questions as well, which is close to development, actually.
Yeah, guys, thank you so much. We've got one more question from the audience, and it's, what's the perspective of cloud technologies in big data? Can clouds expel on-premises solution in future? What do you guys think?
I think this ship has sailed. So I think there's only regional variation. So one of the great things about working at EPAM, among many others, is the ability to have a global perspective, because we work with so many customers across different continents, and cloud will or is already replacing on-prem in majority of scenarios. We had holdouts like healthcare, government, banking and finance for a very long time refused to move anything to cloud. This is happening now, and the question very often is not whether we should do it, but how we accelerate that, how we get even to the next level. There are some regions that for various reasons aren't as advanced in cloud migration, but from my perspective, this is only a question of time. And in fact, I look at the moment, after Middle East for EPAM for data practice. And that was one of the regions that was very resistant. Now all the cloud providers invested heavily in the local data centers, and this migration is accelerating at a rapid pace. And cloud, very often cynical people say it's somebody else's data center, so why bother? I think it's much more than that. You've got multiple layers of abstractions, services that are virtually impossible for single organization to replicate in their own data centers. And that's where the technological bleeding edge is right now. That's where really complex problems are being tackled and solutions are being provided. So it's only a question of time before data centers on-prem are going to be a thing of the past.
Yeah, but
Tom.
I think we cannot. I don't think we can not completely get rid of on-premise infrastructure, because there are some environment like chip manufacturing, like ships, systems that are completely disconnected from internet, and there is no way to bring it there. When response time is important, but I think with a combination of edge computing, it helps you to combine the kind of power of cloud and the kind of locality of edge computing to bring algorithm, trained algorithm to the on-premise environment and help you to use all of this kind of insights learned in bigger analytical environment in specific situations. There is a tendency to embed make these cameras smarter, just do all of this kind of computer vision, like image recognition and object detection on the edge, just make sure that it's fast, because some kind of cases are very time sensitive, and if there is any interruption in the internet, you probably can risk somebody's life. So in this particular case, I think it will still exist. But I think overall development environment and overall storage environment definitely is on cloud, and I don't think there is no single organization who's still considering it. The question is, what part of infrastructure will be on the cloud and so on.
Yeah, Oleg, so on that subject, you're absolutely right. I just like to point out that edge itself is a cloud concept. So I think what we're seeing is definitely shifting paradigm. How this is executed, you're absolutely right in terms of importance of edge, and we all experience that. Our phones those days will have certain systems like speech recognition, for example, image recognition, security biometrics being embedded in those devices, so they actually don't communicate with the cloud to perform those functions. Nevertheless, they're part of a cloud ecosystem on a higher level.
Yeah, thank you, guys. We've got one more question from the audience, and the question is, can we provide some real production case where we deployed next generation technology like AI or ML, computer vision, sentiment analysis, etc.? And are we really proud of it?
Well, I can think of one example that we've recently worked on. So in healthcare, the surveillance of patients are very important, especially in like care homes or in hospital settings. If you're taking care of particularly old patients, falls from their bed or from their chair are really dangerous, and they can break their bones, they can hurt themselves, and also on the business side, it brings a lot of like additional costs, unexpected costs to the hospital. So we've been working with a health tech firm to develop like an end-to-end solution, right? To detect the patient, detect the caregiver, detect or somebody else, whatever in the room, and then track the patient, understand how the patient sits, how the patient lies on the bed, and really warns the caretaker or the care team if the situation is getting dangerous, right? If not laying on the right position, or they don't have a bed sheet on themselves, or they already, you know, at the edge of the bed, or just fall down, right? And also everything around privacy that we've talked about was also like applicable to this case, right? We needed to do this entire process on the edge device. So because we cannot collect any data, store that data, because of the regulatory requirements. But that's something that I'm really proud of, right? Because it has a real impact on people's lives. Obviously, technology is cool and we are all geeking out. But when you see that, you know, you deliver such a product, especially in a complex environments, right? There are a lot of like partners, vendors, and trying to do the same thing. And when you know, dive into that kind of an environment, and then just take the lead, deliver the solution, and then you actually help people, that's the most, I think, fulfilling and satisfying type of projects. So yeah, I think, I mean, we have many, but when you ask like what you're proud of and real-time use cases, that's something that I've recalled immediately.
Another cute use case when we implemented, it's a kind of pipe investigation. So if there is any damages in pipes, so EPAM helped to build a robot which crawl through the pipes and use computer vision to identify any defects that can potentially damage these pipes. And it's operate in the environment that human will not survive because it's relatively very small and there is no other way how to do this inspection. So, but yes, as Amit mentioned, we have probably hundreds of different case studies in our data science deck, but these two like came to our mind. And if you're interested, you feel free to join EPAM and explore it.
Yeah, great. Thank you. Thank you for the overview. I think the audience is warming up and we've got more questions. So the question is that there are 3 leaders in the cloud services, AWS, Azure, and GCP. Do we see a possibility to create some unified platform that can help to use any cloud service using common interface? Any thoughts on that?
I think this natural competition between cloud providers, they're trying to like secure customer to specific environment, and they're trying to introduce specific services, like unique services, unique for the specific infrastructure. And there is no probably need from their perspective to invest a lot into hybrid cloud and building similar interfaces, because they will be just losing their kind of advantages, like competitive advantages. But I think many customers are moving into the space. I don't think we have any big company who has only one cloud. Some of them, they have like 2 of them. Some of them are exploring the 3rd one. And it's moving forward. So on the long run, for data management perspective and this data mesh concept, we definitely need to think about some kind of hybrid environment. But which services can you use? Is it going to be one single interface which will cover all these clouds? I don't think it's realistic. But if we build our platform properly, like microservice architecture, that when we don't care too much about the specific technologies underneath, but you provide the interface to access this data, in such environment will probably can live on hybrid environment very well and a distributed environment as well.
Yeah, that's a very good point, Oleg. And I think cloud providers will do everything to avoid situation when they just become commodity products that can be unified under one umbrella. On the other hand, they are forced to think about integration with other cloud platforms, purely because, as Oleg said, there's so many clients that can have footprints in 2 or even 3 clouds. And to extend that, there are sort of attempts to do that both from Azure, which provides now capabilities to integrate across different clouds, but also, for example, from GCP and recently going to general availability, especially in data, OmniQuery for BigQuery, which allows you to integrate and query data from different clouds in one place. Will that lead to one common interface? I'm doubtful. However, as Oleg said, designing your platforms in the right way it will allow you to achieve a high level of convergence across those three clouds, if that's the requirement.
And maybe one more addition to that. If you know how you really need to abstract, these platforms on a higher level, I think you can work your way out. We've been working on platforms like for data science and MLOps that is actually cloud agnostic, that you can basically utilize different services from different cloud providers within the same environment, and you can make those accessible to the data scientists or machine learning engineers. Yeah. And so I think also, yeah, in this hybrid model, the industry maybe is also tending towards that direction more and more.
And just a little note. So hybrid model is not about technology only, right? We don't need to forget about how to use it. So to make it fully operational from the organizational standpoint, how to support it. I think even we have some technology which can bring these clouds together, we definitely need to develop some new organizational model which can successfully operate them, so they bring as much value as they intend to by design.
Yeah, thank you guys. Thank you for your answers. I think we've got this question covered, and hopefully the audience did get all the valuable insights from you. We don't have any other questions at this point, and to be conscious of time, we've got 2 to 5 minutes left. Is any recommendation maybe for our audience? Where are we going? What people should be looking at? What people should start learning? Or what technologies basically do you think will be evolving tomorrow?
Okay, I think I can start. So definitely cloud. So if you don't have cloud yet, I think it's time to find a good training, and it doesn't matter which cloud you will choose. So you can choose like Google or Azure or AWS. All of them, they have interesting, good trainings, and it's a good starting point. The second one, if you more advanced engineer already have some background, learning ML to some degree, because it's becoming kind of inseparable part of data work on daily basis, and became closer and closer. So we see it was time when we had like data science team who works independently, and there is a data engineers who are processing a lot of data and do some magic. But this convergence, it's coming to the place. So we see more and more machine learning algorithms and using even GPU enabled instances for the data preparation, because all this kind of matrix multiplication and acceleration can help you not only with machine learning models, but also with the data preparation, because you can do a lot of interesting things there if you figure out how to multiply matrices and operate matrices. From this perspective, it's probably the right way to go.
Yeah, to add to that, which is really, really good advice. If you look at how the modern teams operate, what's really important is to really learn well the collaboration tool set, as I call it. So really understand platforms like, for example, GitHub, Azure DevOps, generally Git, and learn as well key DevOps concepts. We talk about DevOps, MLOps, DataOps. All of those are variation on the key concepts that any developer, any engineer will need to utilize in day-to-day work. So really spending a little bit of time to understand the key concepts, the key technologies, and how to effectively utilize it when you collaborate with a wider team is a key here.
And I would like also to emphasize like the importance of data management. So because you will not be only changing data, moving data, processing data, but also make it of good quality, available, and so that it's fulfill the needs of advanced analytics, machine learning.
Thank you, Peter. Thank you, folks. I think we're coming to an end, and I'd really like to thank everyone for being tuned, for our audience, for their fruitful questions. And special thanks for our panelists. Thank you guys for making it happen. connecting from all over the world, time zones, day off. Thank you really so much. Very great conversation. I do hope we'll have more panel discussions in the future. We'll be announcing them on our website. And I do really encourage everyone to participate, to post your questions, to jump into those discussions and contribute as you can. Thanks, everyone. Hopefully you'll all have a great weekend. I think that's it for today. Thank you again. Have a good day. Bye-bye, everyone.
Thank you.
Thank you.
Bye.
Have a good weekend. Bye-bye.
Ну що, колеги, ось і добіг до кінця наш сьогоднішній марафон. Не побоюсь цього слова. Це дійсно був марафон, більше 6 годин лайвстріму. Це завжди непросто. Величезна подяка усім нашим сьогоднішнім експертам, ще раз, особливо експертам, які представляли в нас EPAM компетенцію в нашій панельній дискусії. Величезна подяка усім доповідачам і сама більша подяка вам, шановні колеги, друзі, учасники конференції, за вашу увагу, за ваше терпіння, за те, що ви з нами, за те, що вам було цікаво з нами. І сподіваюсь, просто впевнений в тому, що надзвичайно корисно. Хотілося б наголосити сьогодні ще окрему таку річ, як про фідбек. І ми можемо планувати діяти з вами, взаємодіяти з вами таким чином, що вам буде надіслана фідбек-форма, обов'язково на всіх, як зазвичай. Ми це робимо на кожній нашій конференції, після кожного нашого заходу. І у цій фідбек-формі за допомогою цього зв'язку, зворотного зв'язку, ви зможете висловити свої пропозиції, оцінки і, власне, можливо, якісь додаткові запитання, які у вас, я впевнений, виникнуть або виникли. Тому, друзі, наголосимо ще раз, що з EPAM завжди цікаво, корисно і цінно. Дякуємо вам за цей час, дякуємо вам за цей день. Окрема подяка організаційному комітету цієї конференції і усім людям, які доклалися своїми зусиллями для того, щоб ця конференція стала дійсністю. Дякуємо вам і до нових зустрічей в нашому ефірі.